Hello, everyone. This is Patrick Chen from Alibaba Cloud team. I'm a regional solution architect from Alibaba Cloud Hong Kong, Macau, Taiwan, and Philippines region, and specialize in digital government and smart city. So today's topic is Alibaba Cloud Scalable 5G network as a service to build future industrial ecosystem. In this topic, I will more focus on how we Alibaba Cloud team enable the ecosystem and also the community to build the future smart industry city. Okay, so today agenda, first we will recap about the Alibaba Cloud in how we make use of the technology and enable our different industry and ecosystem for the digitalizations, transformations. The second part will be recap about the smart city ecosystem principle and also share about our industrial solution scenario. In some is already landing. And third, we will recap the core cloud elements in smart infrastructure to support the community ecosystem to build the urban application systems. Okay, first, let's take a look at a video.
The world is about to change. Are you ready for what lies ahead? Because we are going full throttle into a new digital norm, where it becomes the pulse of all future businesses, the lifeline of every economy, brains of cities, and heartbeat of enterprises. This pulse will unlock new modes and empower new ideas and innovation. Our heritage has already kept us ahead of what's next, even when the world paused. We never stopped. We never gave up. We went fast forward, ahead into the future, and became the digital metamorphosis that went beyond borders. The pulse of digital economy will elevate. The pulse of new business will accelerate. The pulse of new industry models will ascend. Together, we will co-create the new world, because we are the pulse of digitalization.
All right, that is amazing video to recap how Alibaba can leverage our technologies, solutions to enable different industry for the digital transformations. Okay, let's recap to today's more related to smart city principle and ecosystem. So here is a slide to initiate the concept of in 3 layers. The first layer is about the urban planning and government policy that will be driven by the central governments or city governments in terms of the policy design and governance in how the top level see the smart city will be in development, management, or sustainable perspective in driving the smart industry, smart city. And based on different priorities and also time to time by the central government and city government, and then it will become the different policy aligned and recap in different focus area, like the smart transport, government, mobilities, living, economy, constructions, environment, village, and medical, and etc. Those are the core focus area that will mainly serve two things. First is make the citizen living happiness. The second is to let the government in governance, in management more easier and make the city will be better. And in this area, that will be more important for working with our smart innovation and technology ecosystem in different area, in different city, and to cooperate and design and deploy different urban application and operation management system. So on the bottom is the core foundation of the urban smart infrastructure that Alibaba Cloud will definitely take in the core positioning. We provide the well and mature public cloud and hybrid cloud infrastructure and supporting those innovative elements. For example, the AI platform, the cloud platform, the IoT platform, the data platform and analysis, and also the security platform that we call ACIDS, that we already have the well and mature components to support our ecosystem for different urban application development and management. So here, I would like to recap some of the leading and also deployed applications in different cities. For example, we have the smart transport for airport traffic management in Hong Kong is already landed. In this case, we are serving the Hong Kong Airport Authority as an end user. During our conversations, we make use of the real-time and system data from their airport applications, and then go injected into our data backbone. In our data backbone, that we set up the corresponding data structure and capture those real-time information, not only the system but also the flight and also the gate scheduling and etc. for the injection data. During the data filtering analysis, we can do some recommendations as an advisor to the management. So the next screen is sharing about the data visualization we call Data we have already built it and deployed it in Hong Kong Airport Authority, running on Alibaba Cloud Smart Infrastructure. So in this screen, you can see that we capture the real-time information for the flight, the gate, and also the underlying schedule system, doing the visual and analysis of data, and present in a amazing report with the KPI matrix that can be integrated in one screen. And also, it definitely can provide better deployment resources and enhances the operation efficiency from the advisory and also the operation manager perspective. And it also helped the Hong Kong Airport Authority to plan the future smart city, smart airport. Okay, this is the second case. It's about the smart constructions. Also, you can see that the smart constructions for the BIM, we call the BIM information modeling, that we have already support the smart INT partners that they are also not using the 4G, and also is also testing the 5G in increasing the networking and the performance with the low latency, and support these
醫院項目簡介，
BIM
醫院嘅負氣壓病房可以容納超過800張病床，正係進行前期工作。
Yes, so you can see that the BIM solution has been deployed in Alibaba Cloud Infrastructure and showing the major information of the construction and also for these hospital and community facilities. Let's also take a look the BIM model and solution on Alibaba Cloud reference architecture. So you can see that in terms of the BIM ISV model, the application can be successfully deployed in Alibaba Cloud infrastructure and providing with our cloud computing with the secure solutions, log management, and also the API is supporting the application workload and transaction. And there will be some area we can expand that will help the BIM partner to build more smart BIM solution with Alibaba Cloud Service. For example, the BIM portal can be deployed, rolled out, and serving the end user. Okay, the end user, no matter it's a management or the worker in construction site. So through the 5G, it can also accelerate the network latency and then do the fast access and retrieval. Working together with Alibaba Cloud network solution, we call Elastic IP. We not only provide the public IP for the local site, but also we have the option, we call it Elastic IP Premium for faster channel access. So that is a great solution for like the manager or a specified audience. They are located in China, but they need to ongoing access the BIM portal to retrieve the information and transactions in faster way. The second part will be about the security. Alibaba Cloud, we already have the SaaS service in security like entity logs, web application firewall, or security CDN that can support the BIM solutions and provides a faster security service. And the third part will be about the real-time for the enterprise data dashboard that I have mentioned before. In this case, you can see a demo for Guangzhou and build a build model with the data visualization to showing the modeling and also some city matrix. And with the 5G, the fastest network service connectivities, that the dashboard can be display a huge and large information and put not only in the desktop through the Wi-Fi, but also can push back to the iPad or mobile through the 5G network. The fourth part will be about the video surveillance or the live streaming that the BIM partner can also enlarge the usage using our cloud backbone with the live streaming services together with 5G, the video surveillance and the live streaming will be much more better. Okay, so this is the first case about the smart living for the customer chatbot in one of the Asia Pacific city for the proof of concept. In this case, that it provide the human-machine interactions that will provide the navigations, intelligence, voice answerings, route planning, and etc. So in the backbone, we can provide cloud and AI power with algorithm and also to support the kiosk as a client, and then do the human-like and then do a faster and chatbot service to the end user. So for the next, if 5G will be adopted, I would believe that the kiosk or the communication channel can be expanded to the mobile phone or the iPad with 5G network, with the faster recommendations and etc. So what behind is the Alibaba Cloud AI backbone to support the kiosk applications. So in this case, you can see our 6 core value propositions. The first is about the humanoid character that we base on our algorithm. We can simulate what the real human being, and then to simulate and also to capture what they are doing and the interactions. The second part will be about the real-time avatar that just like the real person to talking to you during the chatbot. The third will be about the multi-model for automated roll-up with the voice activity detection that will more intelligent to understand what the human talking and being in fast roll-up, real-time voice, and etc. The fourth will be about the English and Chinese. We support multilingual and also the some of the accents that from different culture. And the last two pieces will be about the microphone array technology that can acquire the computer voice and also reduce the background environmental noise and make the chatbot and also the communication more smoothly. And the solution will be well proven in mainland and also some of the overseas city for the landing. And also, we have the solutions already in our different business units like Tmall, Taobao, and Lazada. All right, there are more than 3 cases what I have shared before. So we have more smart city landing in a smart industry with the black tech practice in mainland or Greater Bay China City. So as of today, we have deployed more than 30 cities with their urban sustainable platform to support the smart city initiative and landing, including our headquarters Hangzhou, also the Macau, Guangzhou, Chengdu, Shanghai, Beijing. Those are we based on our philosophy and also our expertise with our best practice to work together with the local governments and the operator, and based on their priority like the smart transport, tourism, urban management, and etc. to deploy the application landed in the city and serving to the citizen. There are more examples that we can share much more once connect offline with our representative. So building the new smart infrastructure is really important. For example, for the smart transport, that is always, but not the must for the smart city first killer application. So it is because this transport is the major pain point for almost the big city. So in the smart transport perspective, we have already a ready-made visual engine with the scene analysis algorithm. And also our best practice and our core foundation and support the smart sense infrastructure, like working together with LTE 5G or the NB-IoT, NORA, and different protocol in terms of the IoT that working together and build a smart and sensible infrastructure with the not only the edge and also the sensors powering, but also for the middle and for the back end for the cloud computing, networking, and processing power for the complex calculation and the recommendation to the result. Also, we also have the high precise map. We have the A map, Chinese we call 高德地图, and that will be part of the Alibaba group service, can well integrated with the different smart city project for the like the smart routing, recommendation, point of interest, and etc. We also have the other scenario like smart parking and also the smart cone barrel that will together with the IoT, safety, facility, innovation elements in the backbone. The last thing will be about the mobile as a service. That is one of the key trends in allowing the digital city, or we call digital twins, that make the service is more user-friendly, and for the end user perspective, for example, the driver. Okay, we expect that for the driver, they have the single app, we call it e-mobility, and then they can make use of the app to enjoy the service they want. For example, where can I park my car? Does it have the vacancy? How much is it? Where is the closest tunnel to the destinations? How is the weathering outside? Etc. Those are the personal and also the information that back to the driver at that point, that what make their decision to the destinations. All right, that is the second part, and also we kept the industrial sharing. So the last part will be about the core cloud elements in smart infrastructure from Alibaba Cloud side to support the different smart city scenario together with 5G and IoT. So Alibaba Cloud global infrastructure. As of today, we have 23 Alibaba Cloud region and 70 availability zone, we also call data center. In Hong Kong, we have 3 availability zone, and in terms of the mainland China, we have lots of the availability zone from the north to the south, and from the east to the west. And also, we have different data center region in Asia Pacific city like Singapore, Jakarta, KL, Sydney. In the meantime, we have the different data center in we call One Belt One Road, that Dubai, Mumbai. Also, we have the data center in US and also the Europe. We also provide the huge of the CDN nodes from different city all over the world that will enhance the faster distribution of the content. Meanwhile, with the smart scenarios like cross-country or cross-border, that between different regions, for example, the Hong Kong to Shenzhen, Singapore to Europe, we can have the local dedicated network between each data center across different regions and provide the fastest access with the protected and secure network channel for the application rollout or transmission. That will help the smart ecosystem, enterprise, or even different smart city government for the application rollout. We also take care mainly about the security compliance. As of today, Alibaba Cloud has addressed most of the security standard from a global perspective. For example, we have already fulfilled the ISO, the Cloud Code of Practice in Cloud Computing, like 27001, 27017, 27018, etc. And also, we can meet some of the regional standards, like C5 from German, MTCS from Singapore, and other industrial practice like HIPAA for health. For the privacy protection, we are very concerned about and also address this area. So we have also fulfilled, for example, for Hong Kong, we address the PDPO requirements, and also for the Macau. And also we have the different privacy, like the GDPR, we already make it ready and support. All right, so back to the core cloud elements we call ACIDS. For the A side, that we have the AI intelligence in the backbone from public cloud or the private cloud, we can base on the different technologies and the intelligence like AI chatbot, speech recognitions, image, video. With the 5G network, we can enlarge the scenario usage to capture much more data and capture much more high resolutions of the video or the image and become more intelligence, more data, and provide more advisor to the smart city. With the backbone of the platform AI, we support different algorithm, allow the community or the developer to upload their content, their algorithm, and then build the workflow with the simulations that we provide the one surface experience for the visualization for the output in terms of the model training, evaluations, or model serving. C is about the cloud platform. We already provide the mature compute cloud network, storage, and also the networking solution to address the different computing scenario needs. We have provided lots of the computing scenario solutions for different scenario. For example, the high clock speed or the high GPU for the lots of the AI or algorithm that also we provide the back-end computing processing power and also support the backbone like backup, resilience, recovery, availability, and etc. For the storage that we provide the different storage options for the applications like block storage, object storage, and table storage for different scenario usage with the high service level agreement. For the network side, that if the community or the partner or the application that not only deploy in the local city, but also that will leverage the ecosystem go into mainland China. Alibaba Cloud side, we have much more about the network solutions, product, and also we have the local infrastructure and across to the global for the connectivity between each data center. And also we provide the elastic IP premium for low latency Go China network. And also in terms of the technical side, we have lots of the networking solutions that, for example, for the public internet, we provide the EIP, we provide the SLB, we provide the NAT that make the underlying resources, the ECS or the other cloud connected resources go outside to the internet. And with the 5G, with the fastest network service, that will help the fast connectivity from the end user perspective. And also our elastic IP can support large bandwidth, and it can be charged by the pay as you go or pay as traffic or pay by bandwidth that support different 5G scenario usage. Also at the back, we have the hybrid cloud solutions that can connect between the public cloud and the private cloud in customer managed resources. For the I side, that will be integrated 5G and IoT. So in a typical 5G application, that will including the mainly three parts. The first part is about the edge. That will be about the mobility or the different IoT sensor, the trip, or the local edge gateway that is supporting with the IoT partner and also the local carrier with the standard. The second part will be the middle. Is about the network connectivity to the cloud. That is almost driven by the industrial protocol standard like 4G, 5G, and also for the NB-IoT, LoRa, 6.4, Wi-Fi, and etc. And the third part will be about the backbone. That will be much more about the Alibaba Cloud positioning. We can provide the IoT City Link platform running on the public cloud or the private cloud to support the IoT hub to retrieve lots of the sensor information, data injection, and then pass through to the cloud backbone for the data analysis with the AI and the recommendation back to the end user. And lots of the computing product portfolio that can be mixed and matched, powered by Alibaba Cloud to develop and deploy in different scenarios. For the D side, that will be the database, service, and product. Alibaba Cloud, we provide different database options to support different database application scenario like OLTP, make use of the relational database, or for the fast QE, we can make use of the data caching, Memcache, MongoDB, and etc. For the Oracle compatibility, we have the PolarDB with the faster performance to compatible the existing Oracle applications moving on the cloud. Ultimately, it provides a lower TCO with the faster system operations and maintenance and operation management. So working together with the big data and AI, Alibaba Cloud, we provide the full suite of the data injection from different sources and then store in different data storage options. Doing the data processing by different elements like big data, max compute backbone, the data lake analysis, stream computing, we can proceed a fast visualization of those data by the big data, quick BI, data V dashboard. Ultimately, can work together with the AI power service like the PAI, recognitions, OCR, NLP. We can provide the AI driven with the big data to the target system or mobile app. As the lastly will be about the security. Alibaba Cloud side, we have provided full backbone end-to-end security from the transmissions, also applications, data, network, security, etc. We have lots of the security component to address the end-to-end security protection when the application moving on the cloud. For example, one of the solutions is a secure DCDN. It is a combination of the secure service, make use of our NDDoS, web application firewall, TLS encryptions, block mitigation and management. We can provide the accelerator of the website in terms of the web traffic for the fast keying and integrated the security and protect the origin server in the back end. So actually, there is more than what I have captured. Alibaba Cloud, we are the cloud backbone, we are the cloud platform, is provide the sustainable innovative. We have more and more cloud service portfolio under the infrastructure as a service, data intelligence, industrial and application engine, and supporting our government, ecosystem, partner, community to ongoing enhance and build their application, but start from small. So lastly, is about my summaries that Alibaba Cloud is not only a public cloud. We are more than just cloud. We can provide the smart cloud infrastructure and advisor to the partner, ecosystem, and community, and works as your partner and let you to build the urban applications by modeling the infrastructure on the cloud, fast building the distributed and agile platform, and creating data-driven and smart intelligent urban application. Make use of our core elements we call ACIDS and deploy it on the public cloud, hybrid cloud, or the on-premise private cloud to address and meet different government and smart city needs and requirements. All right, I think that's my time. Okay, that is finished my presentation and sharing. So definitely, I look forward to working with you as an individual or the enterprise to talk about how the smart city will be and what is your requirements. Let's communicate to our local city representative. We are more than happy to listen your requirement and your voice and feedback and work together and deploy a smarter city. Thank you very much. Thank you.
When it comes to IoT solutions, the future brings infinite possibilities. From decongested cities, smart homes, and to devices that interact with you, IoT is set to be the catalyst in transforming the way we live our lives. At Alibaba Cloud, we understand these possibilities and quest to take it one step further. Our IoT solutions are already changing cities, events, industries, and vehicles. This is made possible through the combination of cloud computing, big data, and AI. Let us better understand the applications of IoT with Matt and Alex. Matt and Alex are waiting for their bus at the bus station. As they wait, a screen on the bus stop notifies them of a delay due to full occupancy. The next bus arrives exactly at the estimated time shown on the screen. Wondering how this is possible? Powered by Alibaba Cloud IoT, the bus takes the fastest route to the bus stop while avoiding traffic congestion. Thank God for Alibaba Cloud IoT. I remember how I was stuck in traffic for over an hour a few months ago, remarked Matt. As they reach Matt's apartment, Alex was surprised to see that the room temperature was already adjusted by the smart temperature controller before they arrived. He also finds Matt switching on the lights and the coffee machine using his phone. Seeing Alex amazed, Matt shares with him the numerous applications of Alibaba Cloud IoT, all made possible with the Alibaba Cloud IoT suite. Alibaba Cloud IoT comes with 5 primary features. High traffic endurance. Handles high traffic scenarios smoothly using enterprise distributed application service. Equipment certification. Eliminates security risks by certifying every connected device with a machine secret equipment certification. Secure transmission. Ensures data integrity and confidentiality using a TLS standard data transmission channel. Device rights management. Provides users device-based permissions, device rights management, and cloud communication. Reliable message service. Forwards data to the MNS based on the rule engine, ensuring upstream data reliability. As they sip their coffee, Alex realized that the future promises endless possibilities, made possible by Alibaba Cloud IoT. You too can transform your business or infrastructure by visiting www.alibabacloud.com.
All right. Hello and welcome, everyone. I'm Jeremy Peterson. I'm a training advisor here at Alibaba Cloud, based in Hangzhou, China. Today, I'm going to be presenting serverless and DevOps on Alibaba Cloud. So we'll be introducing serverless tools and DevOps tools that can help you make the most of Alibaba Cloud. This will be a quick introduction. We'll go through some basics, and then we'll have a few demonstrations so you can get a feel for how things are done hands-on. So we'll be breaking our presentation into 6 sections. We'll start with DevOps and Cloud Native, a quick overview. Then we'll talk about DevOps tools and workflows. Well, from there, we'll move on to Alibaba Cloud Function Compute, and then we'll have a demo of Function Compute so you can see how it works. Then we'll talk about Alibaba Cloud's serverless Kubernetes service, as well as our container registry, which is a private service for hosting Docker container images. And then we'll have a demo of serverless Kubernetes and container registry together. So that will take probably about 2 hours. So buckle in and we'll get started. I want to start with a quick overview of DevOps and cloud native technology in general. So cloud native itself is a story of waves. You can think of it as changes in the hype around various design patterns over time. So, the early phase of what now might be called cloud native was just regular old virtualization. So think Xen Hypervisor, KVM, VMware. The first phase in what has now become cloud native technology was actually just the shift toward virtualization. That's what enabled providers like Alibaba Cloud and Amazon to build public cloud services in the first place. That was followed later by the enhancement of what we now call infrastructure as a service. So this took other parts of the IT stack, like network configuration, DNS, these sorts of things, and converted them into services that you could interact with programmatically through an API or through tools like Terraform. And then later we moved into containerization. This has been the hot thing since Docker came onto the scene. So now many applications are being containerized and deployed into orchestrated container environments like Kubernetes, which we'll talk about later. And then the final wave, well, probably not the final wave, there will be more after this, but the hot new thing is, of course, serverless, which is moving away from having applications run 24/7 and instead focusing on having functions run in response to an event or a trigger. So AWS has their Lambda service, we have our function compute. What these things do in the background is they actually run a container. So they'll run a container in response to an event. So the container gets booted up, loaded into memory, it does its one task, and then it quits. And as a consequence, with serverless services, you're charged only when your function is triggered, which is really, really cool. That's sort of the latest wave in this move toward fully cloud-native technologies. Obviously, that's something that's difficult to achieve on top of your own infrastructure, but if you're using a public cloud, serverless is very achievable and very accessible. Alibaba Cloud itself is all in on cloud native technology. So this is fast becoming the norm for us internally, and we think it will become the norm for a lot of companies moving forward, which is why we put so much time into it. But before we go any further, I feel I should define, as best I can, what cloud native is and is not. So cloud native is not Kubernetes. It's not microservices, it's not immutable infrastructure. It's a combination of these tools and techniques for deploying and managing applications. For something to be cloud native, really all that means is it's an application that's deployed in a way that makes the maximum use of new technologies offered by the cloud. It's not a particular technology or set of technologies or even a particular philosophy. It just means that you are all in on the cloud and are doing your best to take advantage of the services that are offered by modern cloud providers. And that could span not just across things that are traditionally considered cloud native tech, like Kubernetes or Docker, but also things like various big data and analytical tools that are provided by the major clouds. For instance, Alibaba has a couple of fully serverless data analytics tools like DLA, Data Lake Analytics, that you can use to do offline analytics and queries. And integrating something like that into your stack might be considered cloud native. Same thing for AI. Many cloud providers, Alibaba included, now offer services like Alibaba's Pi, Platform for AI, which allows you to build artificial intelligence applications and machine learning applications easily with low to no code. You can do a lot of it just by dragging and dropping blocks onto the GUI interface in the Pi console. So these things are made possible by the cloud, and these are things you could probably not do off cloud in your own environment, and that's sort of what makes them cloud native technologies. They're taking advantage of unique features of the public cloud. So cloud native, as I said, is really about finding new and innovative ways to launch, operate, and develop applications. So cloud native tech focuses a lot on the application management lifecycle. So you're trying to find ways to speed up and improve development, deployment, running, iteration, and retirement for your applications. The job of most cloud native workflows is to make that faster and more efficient. So you're looking for scalability, reliability, observability, operability, if you will, ability to operate your application easily, auditability, can you see what's going on with your application and who changed what, and of course, security. Cloud native is about providing those things in the most efficient and lowest cost way possible. So the evolution of cloud native, if we look at the earliest tier, if you will, in cloud technology, it's infrastructure as a service. Pretty much every major cloud, Google, Amazon, Azure, Alibaba Cloud, they all offer this IaaS tier, infrastructure as a service. That includes things like networking, load balancers, virtual machines, permissions management, auditing tools. Those would all be IaaS tools. But there's a big gap between those tools and your finished application. So one of the jobs of cloud native tools is to try to bridge that gap. So for instance, you need resource management and application tools to help you get from these raw computing and network resources up to a functioning application. And that is where cloud native comes in. And to do that, you need tools to help you do a variety of things. The first thing you really need to worry about is configuration management. So how do you make sure all of your servers or containers are configured in the same way? You want consistency of configuration. And there are a lot of tools out there to help with that. One very common one is Ansible. I believe this was originally a Red Hat tool that's now open source. Ansible is really neat. What it lets you do is run what's called a playbook. It's a type of script that runs against your deployed servers or your deployed virtual machines and runs a set of steps. And you can break playbooks into modules, and it's all very cool. And it makes it easy to manage the process of configuring or bootstrapping a new machine, and it can help you batch deploy changes across a large number of machines at once. The problem is, Ansible scripts, there's no real state keeping built into the Ansible tool itself, so you can't guarantee that a script will run the same way twice. If you run a script today and then rerun it tomorrow against the same server, if nothing has changed, what should happen is the script won't make any updates or changes, but you can't actually guarantee that with Terraform. Some parts of the script may be applied again, because no state is kept by Terraform. It doesn't know what the actual state of the server is. It can simply rerun the commands in the playbook. There's also no easy way to confirm that everything in the playbook ran successfully. Short of testing things by hand, there's no easy way to do that. Enter tools like Terraform and Packer. These allow you to do something a little bit different. These use a declarative API. You tell the Terraform tool what you want to happen, and its job is to look at the state of your cloud infrastructure, figure out the differences between what you want to happen and what has already happened, and then apply the changes to get that infrastructure state in line with what your Terraform code says. And that's a great way to manage your infrastructure. You can use that to manage network groups, routing tables, vSwitches, and an Alibaba Cloud VPC. All of that can be defined through Terraform. You can, of course, also say how many ECS virtual machines you'd like to have launched, what specification. It's not really designed for operating system level configuration, but if you're looking for an alternative to Ansible, you can use Packer, which is also a tool from HashiCorp, the company that makes Terraform. Packer can build disk images for you, and then you can use those to launch virtual machines using Terraform. In fact, there's a common cloud native best practice called immutable infrastructure, where you deploy all your changes this way. You ideally never log into your server. You just include everything in the base image that you build with Packer, and then you roll that base image out. And if you need to make a change to the way your servers are configured, you do that by making a new base image with Packer and redeploying. You don't actually log into the servers and change them, which is what you would do with Ansible. So it is actually possible to have a fully declarative, immutable, unchangeable infrastructure where all updates are applied by rolling out a new golden disk image for your instances. I've done this before. It's actually a lot of fun to build a pipeline that does this. If you're a techie or a developer, I do recommend you go play around with Terraform and Packer and try using Packer to deploy virtual machines. It's pretty cool. But of course, that's not the end game. That's not the whole story. In addition to managing your infrastructure and your configuration, you also need a way to manage the overall state of your running infrastructure. You need some tool that's going to do things like handle load balancing and ingress rules and relaunch failed virtual machines or containers, basically something to maintain the overall status of your running application. And that's where Kubernetes comes in, specifically for containerized applications using Docker. Many people will rely on Kubernetes to manage their running containers for them. And of course, much like Terraform, Kubernetes is declarative. You write files in YAML markdown format, and then you pass those files to the Kubernetes API server using the kubectl command, and it will compare your YAML file, which specifies what you want to happen, against the current state of the Kubernetes cluster. It will detect any differences, and it will actively go and make changes to the cluster to make it to bring the state of the cluster in line with your configuration. We'll talk more about that later. If you're new to Terraform and Kubernetes and Ansible and these types of automation tools, I know this is a little confusing. I wish we had more time so we could go into more detail about how all this works. It is pretty cool. Unfortunately, today I'll only be able to give you a brief overview, but I do recommend that you check out the Terraform website and the Docker website and the Kubernetes website if you're new to these things, and start learning them today, because this is really, really critical if you're going to be building applications in this new public cloud, full in cloud world that we're now emerging into. Okay, so again, those tools are just there to help you bridge the gap between your raw underlying infrastructure and your running application. All right, moving on. So cloud native application evolution. So how did we get to where we are? Well, we started with monolithic applications. This is how all applications used to be deployed. The user interface, any business logic, any tools you needed to talk to your database, all that stuff was packaged up together in a single a binary executable. So that could be, something like a jar file. If your application was a Java application, you'd have this one big jar file. All the code for your application was in there. The code for the interface, the code for handling any user interactions, input and output would all be in that one jar file, which was nice in one way because it made deploying very easy. You just, run a shell script on all your servers and tell them to execute this code from this jar file. But it's also very limiting because if you need to update something, no matter what part of your application needs updating, the update is done by redeploying the jar file. So rebuilding it, pushing it out to your servers. So of course, that was limiting for a lot of web companies, especially for a lot of internet companies. That was a limiting factor in how fast they could deploy updates. So we ended up with the microservices application. You'll often find that people who are running containerized applications also have written their application in this way. With a microservice application, you've broken the components of the application into different discrete components that talk to each other over some common API. So you'll have a UI component that presents a view to the user. When the user clicks on something in your web application, that component will make a call to some other service deployed in some other container or on some other virtual machine, and that other service will send back a response, and then that will be given to the user. So in this way, you can independently update these discrete chunks of your application one at a time. So if you need to update something in the UI, you can do that without affecting any of the other parts of your application. If you need to update some business logic, great. You just redeploy that container corresponding to that piece of your application, and everything's good to go. It gives you a major improvement in the amount of time it takes you to deploy new changes. So it lets you iterate faster. So again, with the old monolithic applications were large, single big executable. If you want to update something, you update the whole package, redeploy it. You don't have that problem with microservices applications. And for microservices applications, people are now moving some types of application into what we can call full serverless. This is where your application is event-driven. So things only happen, code only runs when an event occurs. So maybe a web request comes in, so you get an HTTP GET request at some API gateway. Maybe a file gets written into storage somewhere. Those events trigger a container to start up temporarily, run some code in Python or Go or whatever language you want, produce an output, send the output somewhere else, and then shut down. And as a consequence, if you've written an event-driven application in this way, you really only need to pay for the amount of time your code was running and for any public internet traffic that it generated. So this is a big cost savings. You can run serverless applications that handle millions of requests and end up paying only a few dollars to run those apps every month. So it's pretty cool. Probably my favorite example of a serverless application is the acloud.guru website. So they are fully serverless, and I think they, as of at least last year, their entire usage for their website, except bandwidth costs, was in the free tier for, they use Amazon Lambda. So they were in the free tier for Lambda, and they actually run Serverless Con, which is a cool conference you can look up where they talk about how you can make serverless applications. Okay, so again, microservices and serverless, they share some features. They both decouple components of the application so that you can update them independently. So this modularized application building strategy gives you a new way to look at how you build applications and a new way to potentially save money. The big difference is that with a serverless application, you don't need to run your containers 24/7. They're only triggered in response to certain events. So if we look at the tools that have made this possible, packages, jar packages say, if you're a Java developer, were how you deployed monolithic applications in the old days. Docker containers made it possible to split your application into separate parts. Of course, once you did that, you then had to orchestrate these components, make sure they're all running together, make sure they can find each other, set up networking, etc. To do that, Kubernetes came along to help with container orchestration. And now we're moving into the era of the service mesh, where you have a serverless deployment where containers are only run in response to events. So at each stage of this architectural evolution, new tools have come along to make it possible. Cloud native application lifecycle. So we start with development. This is at the application framework layer. So if you're building your own new cloud native application, the first thing you're going to have to decide is, what language am I going to write this application in? What toolkits am I going to use? A common toolkit would be something like Spring Boot if you're a Java developer. You'll then need to decide how you're breaking your application up. If you're going to do a microservices application, how will all the parts work? Then we get to deployment. How are you going to package up your code and get it running? This is where things like Docker and Kubernetes come in. A common open source tool-based workflow would be to manage code with GitHub. Then you would have GitHub trigger an image building service to produce Docker images that contain your code. You'd deploy those onto a Kubernetes server, and then for build testing and integration, you'd use a tool like Jenkins to do that for you. At the run stage, this is where the orchestration and logging tools get into things. So again, you'll need Kubernetes to help you manage your running application, but you'll also need a lot of tools for logging and monitoring. So this is where things like Alibaba Cloud's log service come in, or open source tools like Prometheus, which is a Kubernetes cluster monitoring tool, Knative, which can help you run, I think it's serverless applications on Kubernetes clusters. You'll need these sorts of things at the run stage. So you'll need to know the status of your application. Are your containers healthy? Which API calls take the longest within your application? Are there any long tail jobs that don't run efficiently? You need to start optimizing, and for that you need logging and monitoring data. And then application retirement, at that point you really just need logging and auditing data to make sure your application is still running okay. But retirement really is an important part of the life cycle. You need to think about how you take things offline, and as a part of that you need to think about how you monitor an application that's in retirement before it goes fully offline. So to get to that stage, we need to think about how to containerize existing applications. This is the phase that a lot of companies are in now. They're looking at ways to use common open source tools to containerize applications so that they can be launched, say, in a Kubernetes cluster on the cloud and managed effectively that way. So here's a typical workflow you might have if you're on a major cloud provider like Alibaba Cloud. You'll have some offline toolkits. For instance, Alibaba Cloud has a toolkit built into, a plugin that works with IntelliJ IDEA, which allows you to build Docker files for your applications. You can use a tool like Alibaba's Derek, which is an open source tool which can help you convert your existing applications into a container image. You'll then push that code, including your Docker file, up to an open source tool like GitHub. If you're not a fan of using public source code repositories, you could use GitLab instead, deployed on your own server. You can then have GitHub or GitLab communicate with Alibaba's container registry via webhook. That will build your container image for you. A tool like Jenkins can also do the build and then push the image. That's up to you, whichever you prefer. And then from there, you can push the finished application onto an Alibaba Cloud Kubernetes cluster, or even simultaneously push onto multiple clusters in multiple regions. We are really heavily invested in the open source world of cloud native. We are a member of the Cloud Native Computing Foundation. We're Kubernetes certified. We're a member of the Mobi project. We have a number of developers here who are regular contributors to Kubernetes. We're also a member of the Cloud Foundry Foundation and also the Open Container Initiative. So we're heavily invested in container tech here, including Kubernetes and other open source orchestration and monitoring tools, because we need them internally at Alibaba to do things like run our 11 sales event. If you're new to Alibaba, you might not know about that. So 11 is basically a shopping festival. So at 11, which is November 11th every year, during that 24-hour period, a lot of vendors on our platforms like Tmall and Taobao will provide discounts to their customers. And during that period, because there's so many special discounts and coupons, people jump on and try to get them. So we will have hundreds of thousands of orders coming in per second, and we meet that demand, that scale, with container tech. So we're very heavy users of container tech like Docker and Kubernetes internally. Okay, so I've talked a lot about cloud native. Let's move on to something else. What is DevOps? So DevOps is you can think of it as a philosophy that tries to bring developers and operations people together. So it's trying to combine writing and deploying new code with managing the production environment and avoiding breakage, because typically these two goals are at odds with each other. So the ops team wants stability, the development team wants faster feature release. How do you balance this? That's the goal. So with DevOps, the goal is to bring these two things together, and the primary way that that's done is through automation. So the process from deploying code, from writing code to submitting it to doing tests and building and deployment is automated as far as possible. That way the chances for breakage are reduced, and the ability to have an insight into what broke when, how, and why is increased. So this way, the ops team is happy, there's less breakage, and the dev team is happy, they can deploy more. So Patrick Dubois is the originator of this idea. I won't go into the whole story about him. You can Google that if you're interested. He's a really cool guy. The idea is to just bring to make the software development lifecycle as short as possible. We want quality and scale, and efficiency, but we also want cost savings. And the best way to do that is get the dev team and the op team working together. And the best way to achieve that is through automation. So there's a lot of DevOps tools. It's complicated out there. So some companies have actually gone out of their way to try and summarize them all. And the end result was the DevOps periodic table. Yes, there's really that many tools. It's in the hundreds. So figuring out how to do deployments and automation is a big challenge. We won't go into too much detail in this course. Basically, this is the workflow we're shooting for. This is a typical workflow, what I have here on this slide. Development and coding, that's usually something done offline on the developer's machine. Code building, that will usually happen via Jenkins or GitLab Runner or something like that. Unit testing, where you test the code individually. Each function will be tested to make sure it does what it's supposed to do. Integration testing, where you test the application as a unit, make sure everything works together. Software packaging, where you typically will containerize everything, put it in a Docker container image. And then software delivery, where you push your packaged application out to your live environment. And then, of course, after that, you'll have regular manual bug fixing and monitoring. So the workflow you use will depend on what your production environment looks like. You could have an environment where you don't use Docker. That's totally fine. There's no rule that says people who do DevOps have to use technology XYZ. You can use whatever you want. So you could be using Git for your source code hosting, and then your CI/CD server could be Jenkins, that then pushes a jar file up to an Alibaba Cloud OSS bucket, and then that gets pulled down onto ECS virtual machines via a cron job. that runs a batch script every hour. There's no reason you couldn't do it like that. And then, of course, if that's how you're working, then you're actually not using a containerized environment. You have a much more simpler workflow that's actually much more reminiscent of how you would deploy a monolithic application, but you can still employ automation for pushing the code out, packaging it, and deploying it. And that will save you time and reduce downtime and errors. If you're using a container-based workflow, things are a little bit different, but of course your developers will start again with committing code to some kind of source code management tool like Git. From there, Git will trigger your integration and testing tools to run. Again, that could be GitLab, it could be Jenkins, it could be something else, it could be Travis CI, that's up to you. That will then push out a command to a container registry to build your container image. You could use Alibaba Cloud's container registry for that, and then you could deploy that container image either onto Alibaba Cloud ECI, our container image, our container Docker container environment, or you could push images directly onto a Kubernetes cluster. Totally up to you. So that would be a typical Docker container-based workflow. So there's multiple ways to do DevOps, regardless of whether you're running straight virtual machines or Docker containers or multiple Docker containers on a Kubernetes cluster. So there's, again, lots of tools to make this all happen. If we're looking at open source tools, that's things like GitLab, Kubernetes, Jenkins, Prometheus for monitoring, Terraform for infrastructure as code, Ansible for managing your servers, Packer for building virtual machine images. Those would be your standard tools. Alibaba Cloud tools, we'd be looking at things like Log Service and Cloud Monitor for monitoring. Code Pipeline, this tool is actually only available on our Chinese site right now, unfortunately. So if you're outside of China, you'd want to use Jenkins or GitLab. For container services, you'd be looking at Container Registry plus Alibaba's Kubernetes service. And then for Glue, to tie your applications together, maybe something like Function Compute. For infrastructure management, if you're looking at an Alibaba Cloud tool, you'd be looking at ROS, Resource Orchestration Service. This is similar to Terraform. Actually, I guess a better comparison would be it's similar to AWS's CloudFormation, which is also a cloud-specific resource orchestration tool. Okay, Docker basics. Before we get into Docker basics, let me just summarize what we just discussed. So we discussed two things, DevOps and Cloud Native. Cloud Native is what? It's the process of finding the most efficient, cost-effective way to take advantage of tools that exist only on the public cloud. So it's about being fully cloud native in the sense that you are taking advantage of all of the unique advantages of the public cloud, things that might not be available to you in an off-cloud environment. And then DevOps is a workflow that's targeted at decreasing the application lifecycle, decreasing the time that it takes you to deploy software from writing the code to getting it into production. Now we're going to look at some of the tools that make that happen, starting with Docker. All right, so I'm assuming for this section that you're new to Docker. If you're not new to Docker, you might want to skip this content. So you could go get a coffee or something. This will probably take about 5 to 10 minutes to explain. But let's assume that you're new to Docker here. So what is container technology in the first place? Docker is not the only container technology in the world, but it is the most popular open source container technology out there, which is why we'll be focusing on it. So containers are a way to package up an application and its runtime dependencies, like a particular version of Go or Python, together and run them as an isolated group of processes on a host. So it's not the same thing as a virtual machine. A virtual machine actually packages up an application plus an entire operating system, and the virtual machine's hypervisor presents essentially a virtual computer to the VM. And so the VM needs to interact with that virtual environment just like it was on physical hardware. So you have to package an entire application, an entire operating system with your application in the VM. That takes a lot of space, so VM images are typically multiple gigabytes in size. They take up a lot of disk space, and they take up a lot of RAM. With Docker containers, your host operating system, which is usually Linux, but of course you could run containers on macOS or Windows as well. Your host operating system provides all of the operating system functionality. The container does not see a virtualized computer. What the container sees is an isolated resource group where it can make system calls and interact just as if it were running under a Linux environment that belonged just to itself. So containers are much more lightweight. They'll usually take up a few hundred megabytes. They use much less RAM. You can get more containers running on the same hardware. So the container density is higher than the VM density on the same piece of hardware because the container is more lightweight. It doesn't need to include a whole operating system. It depends for operating system functionality on the host. And of course, Docker is just the most popular container technology out there right now. So virtualization, if we go back in time a little bit, the earliest proponents of this in the commercial world were VMware. So I'm not sure how old everybody is that's listening today, but I certainly remember VMware. My first IT job in the US, we had a big VMware ESXi deployment where we were running Microsoft Exchange and our Active Directory server. So at the time, this was the coolest thing because I could live migrate virtual machines between different physical hosts. Storage was decoupled from the host, so I could expand and contract storage and CPU and memory resources independent of one another. It was really cool. And then, of course, that later became open source technology thanks to the work of the University of Cambridge on Xen. They worked on Xen, which is a tool for virtualizing Linux VMs, or excuse me, it's a tool for virtualization on top of the Linux kernel. And then later that was replaced around 2006 or 2007 by Kernel Virtual Machine, KVM, which is, again, a hypervisor tool like Xen and also open source and Linux based, but it's a little bit faster, so people ended up moving to KVM for speed and simplicity. I think that was developed by an Israeli company called Qumranet. So the limitations for virtualization is that each environment needs its own VM, and VMs are big. Containers are small, so they take less space, which is the driving force that brought us container technology. Companies like Google and Yahoo needed something that was lighter weight than the virtual machine, so they came up with what I believe Google called C groups, which is a way to run a set of Linux processes in an isolated environment. That became Docker eventually. So 2006 was when Google open sourced C groups. In 2014, that led to the first community release of Docker, and now we're where we are today, where Docker is the preferred developer tool for deploying new applications. And the main advantages here are faster delivery and deployment, more efficient deployment and expansion, more efficient resource utilization, and of course, the slide says simpler management. I'm not sure that's true. Managing a containerized application is actually very difficult, but if you use a tool like Kubernetes, then it can be simple. So I'll let that one slide. You could say it's easier to manage a container as long as you have the right orchestration tools. So we'll get into that a little bit later when we do our demos. All right, so let's continue on to serverless, the future of cloud. And I really do think that it is the future of cloud. This is a technology whose time has come. I think serverless is likely to become the dominant cloud computing technology in the next decade. So way back in 2009, Alibaba Cloud's original computing service was ECS, Elastic Compute. This was fully virtual machine based. You bought a virtual machine, we gave you X amount of CPU and memory, and that thing ran 24/7. That was also, incidentally, the same time that a study by Berkeley came out called Above the Clouds, a Berkeley View of Cloud Computing. And they were saying at that point that thanks to virtualization technology, cloud computing platforms would become dominant in the cloud hosting space, which did happen. Now in 2019, so just a few years ago, that same team has come out with a white paper, I think, called Cloud Programming Simplified, Berkeley View on Serverless, and they're saying that they think the future trend will be toward serverless and away from monolithic 24/7 always-on virtual machines. I'm going to give them some leeway. They were right the first time in 2009. I think they will be right in 2019 too. And we can already see the beginnings of this shift toward serverless tech with our customers here at Alibaba Cloud, and I'm sure the other major big cloud vendors are seeing this too. Alibaba has had a function compute service available since 2017 that allows you to create serverless applications that run as what we call functions. A function is just some code in C or Go or Python or whatever language you want that runs in response to a trigger or an event. So it runs on demand, and you pay only when the function is running. So what do companies care about really during a migration to the cloud? You have to go back to this root question if you're going to figure out why serverless is likely to be the key cloud tech over the next few years. So if we look back at cloud migration 1.0, so the first wave of companies moving to the cloud, the core concern was reducing operations and maintenance costs. So you could move into an environment where you didn't have to worry about cooling or power or backup or redundancy or physically securing your facility. All that was done for you by the cloud provider. That was the major advantage of cloud computing at that time. The core value was this flexibility plus this managed environment you didn't have to worry about. And companies were very focused on resource-oriented delivery. So I want my IT team to give me X amount of resources at time Y, and as long as they can do that under budget, I am happy. Cloud Migration 2.0 looks a little bit different. Rather than being about restructuring, data migration, and cost cutting, it's about innovation and commercial value. So there's a shift toward a different way of thinking where companies are thinking, how can I get the most value out of the cloud? How can I really take advantage of the cloud to drive my company forward in developing new approaches to how we do business and to how we deliver services to our customers? So it's not just, how can I get Microsoft Exchange onto an Alibaba Cloud VM? Now companies are thinking, how can I utilize serverless and machine learning technology and object storage service and all these other things to create totally new innovations or to find new ways to do business or to serve my customers in a new and better way. So it's more about value creation. And function compute, which is Alibaba Cloud serverless tool, is a big part of that for our customers. So the focus is on business value rather than on IT cost cutting. So if you look at one of the major things that was a big plus when companies first moved to the cloud was the ability to do auto scaling. So this was essentially a cost-cutting tool. It allowed you to pay only for the resources that were required to meet demand from your customers. So in the old days, if you were running your own data center, you had to buy servers in advance to make sure you could handle whatever your peak load was. So that was typically more capacity than you needed during off-peak times. Most companies don't have a constant, steady demand from their customers. So you'd end up with servers that were sitting around not doing very much during off-peak times, and then you'd be at or near 100% usage during peak times, if you did your planning right. Of course, it was possible to over or under provision because you were really guessing what your peak traffic was going to be, and as a consequence, you could end up with a system that didn't work very well during peak load because you were under-provisioned and you couldn't meet the demand, or that worked fine but that you paid a lot of money for because you actually had more capacity than you needed. That would be over-provisioning. Those were your two possibilities. It was never possible to really meet your load exactly. You could either over-deliver and have too much hardware that you spent too much money on, or you could under-deliver and end up with unhappy users. Those were your options. With the move to the cloud, it was possible to create and release virtual machines automatically based on your load. Almost every major cloud provider offers some type of auto-scaling service that makes that possible. So most modern applications on the back end are monitoring things like CPU usage and memory usage, and they're using auto-scaling to shrink and grow a pool of compute resources to meet customer demand. That's great. Now you can almost exactly meet demand, but downside, you still have to have some servers running 24/7 to meet those minimum demands, and you're still not able to meet demand exactly because each new server you spin up might handle 1,000 or 10,000 user requests, right? So it's not per request create X amount of resources. It's you're creating the resources in chunks or blocks. So you can still end up over provisioning or under provisioning slightly, even with auto scaling, because you're provisioning an entire VM to potentially deal with just a little bit of load. if you're using something like function compute, where you're on a serverless event-driven architecture, every function that you invoke runs in response to a real actual request. So it's possible to exactly meet user demand. An HTTP GET request comes in, you launch a container, you parse the request, you respond, and then you shut down. So you've run that resource for exactly as long as you needed to respond to that one request, and you ran that container only when that one request came in. So you have this perfect one-to-one match between supply and demand. Also, function-based applications tend to be relatively flexible and maintenance-free because you don't have to maintain the operating system or the underlying infrastructure. You just write the code for your functions and you deploy it into Alibaba Cloud Function Compute, and then we auto-invoke it for you when a request comes in. So it's both lower maintenance than running a VM and also lower cost. So let's take a look at Alibaba Cloud Function Compute in more detail. What can Function Compute do? So Function Compute is part of Alibaba's entire serverless stack. So we have a lot of tools that are designed to make managing and running applications easier for you. Obviously, at the base layer, we have our compute and networking services that we've always had. This is our IaaS, or Infrastructure as a Service tier. On top of that, we have multiple different function compute runtimes you can utilize inside function compute: Node.js, Java, PHP, Python, .NET, even custom runtimes. You can compile a custom function compute runtime as a Docker image and upload it to the function compute service. We allow you to run function compute functions on demand through our scalable services like Elastic Container Instance, so you don't actually have to have any servers provisioned to run your functions. They run only when they're needed, and you pay for them only when they're running. You can tie those into open source tools like GitLab, so you can actually use a DevOps style workflow to manage your serverless application, and you can use our command line tools to help you build and run serverless applications more easily if you're a developer. So we offer 2 CLI tools that help you do this. One is FunCraft and one is FCLI. These are to talk to our our function service. And then, of course, all of this ties into the Alibaba Cloud Open API and our SDK toolkits. So you can use functions to manipulate and interface with other Alibaba Cloud services, and you can build fully functional multi-component applications by combining different functions together and having them call each other. A typical function compute workflow might look like the one you see on this slide here. So typically, again, when you're building a function-based application, you're looking to minimize your application. So you're building the smallest possible units that will do a single task. That's your functions. You can have them trigger each other. So ideally, each function will perform just one single task. You will develop these in whatever editor you prefer on your local machine, push that up to a source code management tool. That source code management tool can trigger the Alibaba Cloud SDK to deploy your function into the function compute service. You will also deploy a trigger for function compute, which will determine when your function should run. And then as that trigger is engaged, your functions will be spun up and run, and you'll pay as you go for those running functions and only for those running functions. So it makes your application much cheaper and simpler to deploy. Your code is packaged up into individual units, these functions, and they are run only in response to particular events or triggers. Cost is low. Functions take only a few hundred milliseconds to spin up, so they're fast, and you can achieve 100% utilization for your infrastructure because the functions only run when you need them to. So if we look at real-life use cases for this, inside Alibaba Group, we have something we call Yuque. This is a wiki-style service we use for internal documentation. This is widely used within the Alibaba Group. We use it a lot for internal knowledge sharing. It's built on top of Node.js, and you can edit documents in Yuque in HTML or Markdown format. Yuque also includes the ability to embed things like formulas and audio and video, and one of the coolest features is you can export a document to a PDF or an image. And that functionality is actually provided by a function compute function. So what we do is we actually pass the Markdown or the HTML that represents the document to a renderer that runs inside of a function compute function. That function will then produce a PDF file or an image file, push it out to our object storage service, and then return a download link that points to that object. And this has a lot of advantages. Number one, we don't have to keep infrastructure running all the time to respond to these export requests, which is good because they're relatively rare internally. Most people just reference the live page. They don't ask for an export. And then when a request does come in, when someone really does need a PDF, we boot up this function. Another big advantage here is security. HTML and Markdown parsers can be a security risk. So the fact that we're able to parse the HTML or Markdown code inside of a one-off throwaway container that's running the function keeps the environment secure. Even if someone's able to exploit a vulnerability in the Markdown or HTML parser that we use, they won't be able to escape from that container. So they won't be able to have a larger impact on Alibaba Group. So it's a safety thing as well. It saves us money, it saves us the trouble of maintaining a lot of servers, and it also helps with security. So let's see that in action. Let's have a quick demo of function compute. I'll walk through with you the process of building a function and deploying it onto function compute in an Alibaba Cloud region. Let's do it. Okay, so let's go ahead and have a quick function compute demo here. So I'm on alibabacloud.com. This is our international website. The first thing I'm going to want to do is actually not go into the console, but go to GitHub and take a look at the function compute code that we'll be deploying. So I'll actually open a new tab first, and we'll go over to github.com, and we can go to Ali Cloud Academy. So Ali Cloud Academy is the Alibaba Cloud International Academy's official GitHub repo. This is where we keep all of our demo code and example code for our courses and for talks that we give. And specifically, I've got some Python-based function compute code here in this repo, function-compute. So you can see here, this is where we keep all our function compute resources. Right now, that just means this one example, meme maker. So what Meme Maker does is it's a function to generate internet memes. So here's an example of an image that was generated by this tool. You can see it's Grumpy Cat. And here's another one. I think this is called Success Kid or something like that. In any case, what this tool does is it can produce a captioned meme image. So the function that we produce takes three inputs, an image URL, a top caption, and a bottom caption, and then it produces an image like this, which you can download. The code is already all pre-written. It's based on Python's image manipulation library, PIL. And to actually deploy this code, we need to create a custom function compute runtime that includes the PIL library. All the code to do that is included here. There's also a utility folder, which includes some handy tools for generating function callbacks. So you need to call the function, so you have to combine the endpoint with the URL parameters. I provide some tools and utilities here that do that. So we'll actually go ahead and start by downloading this function compute repo, and then we'll take a look at the code inside Meme Maker. So I'll just clone this to my desktop, git clone. There we go. I'll clone into the function compute folder. We'll take a look at that desktop here, function compute, Meme Maker, and you can see I've got my example meme images here along with the README. And then I've got my utilities for generating the URL and for fetching images. We also actually need this font package to give us those nice bold letters that we saw. So let me show you those again. So to make these nice bold letters, I need that Oswald font package. That will get included in our function compute image. That's in the utilities folder. And then the FC function code itself is in this folder, FC function. So there's a few components here actually. One is that font package we need. One is the actual function code itself. This index.py is where our function code lives. And then fun.yaml and template.yaml actually define how the environment for our function should be set up. So actually what I want to do is take a look at all three of those. So let me open those real quick inside Visual Studio Code so you can get a look at them. So this is template.yaml. This is actually a resource orchestration service template, an ROS template. What this will do is automatically deploy the resources needed to run our function. So you can see here, we create a meme service called meme serve. This is an Alibaba Cloud function compute service. All functions in function compute are hosted inside of a service. A single service can be composed of multiple functions. You can think of a service kind of like as kind of like a folder that holds functions. Inside that service, we'll create our meme function. Here, the handler will be index.handler. This is a function that we'll find inside the index.py file. The runtime will be Python 3. We'll allow this function to run for up to 60 seconds. If it hasn't exited within 60 seconds, it will be forced to terminate. So you can set a running limit on the time that your function is allowed to run for. The memory size will be 128 megabytes, and the code will run from the root of the function. And then we have to create an event as well that will cause this function to be triggered. So we create an anonymous HTTP GET event. So anytime an HTTP GET request comes into the function compute endpoint, this function will be run to handle that request. And the function, the HTTP GET request itself, along with the URL and the parameters attached to that URL, will be passed to our function so that we can see what parameters were passed by the user. So we'll be able to see the URL for the image the user wants to use and the caption they want to use for the top and bottom text. So this sets up the environment for the function. Fun.yaml, this is a file that explains how to build the custom function compute runtime that we're going to use. So what this fun.yaml file does is it shows us, it tells the function compute service that when we're building the container that will run our function, we need to include the Pillow library, which we'll pull in from Python 3's pip package service. Pillow is the Python library that holds the PIL code, the image manipulation libraries for Python. Obviously, we need that to put the text on top of our image. And then index.py is the actual code for our meme itself. So you can see the license, author, last updated date, all of that. All the libraries we need to pull in are up here at the top. We use the image font and image draw libraries from PIL, as well as requests, IO, and URL lib parsing. And then we've also got libraries to handle logging and talking to other services like OSS, although we won't really use those in this example. We've got some helper functions that draw a nice outline around our white text to make it look more defined. So we draw a nice black outline around our text. We've got the handler function itself. This is the primary function that will be entered when we call our function code. So when an HTTP GET request comes in, this handler function will be the first thing that runs. That will hook into the Alibaba Cloud logger, which will give us some information about what happened when the function ran. The function's context will include information about the event that triggered the function. Including the request URI, which is where we'll be pulling our URL parameters from. And you can see I have a big section at the top here whose job is just to parse the request URL, which will include the top and bottom caption text and the URL of the image I want to use as my meme. And then there's some debugging code in here in case something goes wrong. And then once I get through the parsing for the top and bottom text and the image URL, then I go ahead and do my image processing. So I've got a bunch of code at the top whose entire job is to parse the input parameters and fail, hopefully gracefully, if something goes wrong. And then at the bottom, we've got image parsing code that will try to fetch the image the user wanted to use. If we fail to fetch the image, then we'll respond with an error. If we succeed, then we'll go ahead and use our Oswald bold font to put the top and bottom text on the image. And all this code is set up so that the top and bottom text are actually optional. So I can only put text on the bottom, I can only put text on the top, or I can put both top and bottom text, or I can put no text. All of those should work fine. And then I call my draw outline helper just to make my top and bottom text look nice. And there's some code in here to try to intelligently resize the caption so that it fits the image regardless of the size of the image. So I try to make the top and bottom caption text take up about 80% of the width of the image so that it scales with the resolution of the image itself. And then finally, I write out my output as a binary IO stream. So I just write out the image as a binary file and I return it. Or if something has gone wrong, I just return this retval variable, which contains a string indicating the error. I do that just so that if there's a problem, I don't even have to check the logs. I can just see it as a response in my web browser, which will just render the text of the response. And then that's it. That's all I have to do to make memes. It's just about 150 lines of code, a little less than that if you don't include all the libraries and comments. So let's go ahead and try deploying this to function compute. So if we go back to Chrome, there's some instructions in here that explain what you need to do. If you don't already have Docker installed on your local machine, you're going to need that. You actually need Docker installed in order to build the custom function compute runtime, the one that includes our Python PIL library. You also need to have the fun command installed. So in my case, I already have Docker installed. I recently installed Docker Desktop on my Mac, so I have Docker already here. For fun, I'm going to have to go get that. I don't have that installed. I do have the Aliyun command line tools installed, but I did not install fun. It looks like by default I'm using my Chinese work account. Let's see, I need to install fun. I can do that via npm. I should already have npm installed. I believe it's included by no, it's not included by default. So let's go ahead and install npm first. This is an important first step. So if you're on a brand new Mac, my Mac is brand new. I just got this, I think, last week. Then you'll have to install npm first. You can either do that from the npm official website, or if you're using a package manager like brew, which is what I'm doing, then you can use brew install npm to fetch it. Once you've got the node package manager, you can install the Alibaba Cloud Funcraft CLI, which is just called fun for short, via npm. And then once you've got that installed, then we can get into actually building and deploying our function. And building and testing the function and deploying it are separate steps. You'll see that in just a moment. So I'm just fetching npm now. As soon as that's installed, we'll be able to move on with the tutorial. So you can see here, I have two steps I need to follow. Fun build will make my custom image as a Docker container. Fun deploy will push it up to the function compute service, and it will create the meme SRV service as well as the meme function compute function. Once those are all deployed, the fun deploy command will return some information to me about what the function compute endpoint address is so that I can call it over the internet, and then I can use some of the helper functions that I included in the GitHub repo in order to try calling the function. So let me see how we're doing with the install of npm. That's not quite done yet, so let's just look through the tutorial a little bit more. So I need to test things out. To do that, once we do fun deploy, we'll get the URL endpoint for our new function. Then we need to generate a call to that endpoint that includes these parameters: image URL, top text, and bottom text. I should point out, though, that if you don't attach a custom domain name to the function compute endpoint, then when you call the function compute function, the response from the function compute service is going to be downloaded directly to your laptop. It won't display in the browser. We do that for security reasons. Actually, we use the same rule set on our OSS object storage service. If you don't have a custom domain bound to an OSS bucket, then when you try to fetch a file, even an HTML file, your local browser will download that file. So I'm going to actually go ahead and bind a custom domain to my function as soon as it's deployed. That way the images that are returned will display nicely in the browser. That's because we force the content disposition header in the HTTP response to attachment instead of inline when you're not using a custom domain. If you don't know what that means, don't worry about it. It just means that if you want to see your function compute functions output in a browser, you need to have a domain name attached to the function compute endpoint. But if you don't have a domain name free that you can use, no big deal. The response from the function will just be downloaded to your downloads folder instead. So you'll have to look for it there. All right, so we're still downloading npm, so we need to wait a couple of minutes for that to complete before we can continue. So let's go ahead and wait for that. And tell you what, once I have fun installed, we'll come back and continue. Okay, so we're done installing the Node Package Manager, NPM, and I've used that to install fun. So before we move on, we actually need to run fun configure. So let me show you that. If I type in fun, you'll see amongst the many commands I can use, fun config is the first one here on the list. When I run that, I will need to put in an access key and an access key secret that will authorize me to push my code up to Alibaba Cloud. So I don't have an access key yet, so I need to go set one up. So to do that, I'll go back to the alibabacloud.com homepage, and I'll go over to the console. And from here, I need to go to RAM, Resource Access Management. This is how permissions management is handled on Alibaba Cloud. So I will type in RAM here in the search bar. So again, to get here, I just moused over this orange button, moused over products and services. That opened up the search bar. I typed in RAM, and then you'll see down here I have Resource Access Management showing up at the bottom under my search results. I click on that. That takes me over to the RAM homepage. And from here, I can set up a new RAM user and give that user an access key. So I'll create my user, FC user, function, compute user, and I won't give them console access. This is not a user that needs to log into the web console. They only need programmatic access to the API. So I'll check programmatic access here, and I'll click OK, and that will generate an access key ID and secret for this user. And you can only see the secret here one time. You can see the access key ID anytime you'd like from the console, but you'll only be given access to this secret once. So it's important that you save this somewhere safe. If you want, you can download it as a CSV file. If I click on that, that downloads the username, access key, and secret for me, and that way I have a local copy. So what I need to do from the command line is fun config. First thing that will ask me for actually is my account ID. This is the user ID for my account. I can get that here right under my username from my little avatar in the upper right. Paste that in. My access key ID, that's this value here. So I'll copy that to the clipboard and paste it in. My access key secret, copy that and paste it in. And then I need to choose a default region. So I can choose any Alibaba Cloud region that supports function compute. I believe that's all of our regions right now. I think I'm going to go with AP Southeast 1 here, which should be Singapore. Let's go with that. And then my timeout for invoking the SDK, 10 seconds, the default is fine. Maximum retries, 3, the default is fine. And I do not want to anonymously report usage statistics to Alibaba. You can choose yes or no depending on your personal preference. And then I can choose whether or not function compute is going to use a custom endpoint. We'll say no for now. I can add a custom endpoint later. That's it. I've now set up function compute. So I need to go to my function compute directory here. Oh, whoops, excuse me, don't need that quote. Okay, go to meme maker, ls. My code is here in FC function. I need to run fun build to make a copy of my function. That will invoke Docker. And then I'll run fun deploy, which will invoke the Alibaba Cloud Resource Orchestration Service API, which will then actually deploy the function onto Alibaba Cloud for me. So fun build. That's our first step here. That should follow the code in template.yaml and build our function for us. So you can see it's pulling down the function compute Python 3 image as a first step. Then it's going to basically run a Docker container from that image, run pip to install the Pillow library, which includes Python PIL, the image processing tools for Python. And once that's done, it will produce a new Docker image, which I can then push up to the function compute service along with my trigger, which is, remember, just an anonymous HTTP GET trigger. Will cause this function to run. So we just need to wait for this to complete. This could take a couple minutes. So let's just wait for that. Once it's done, I'll be able to run fun deploy. And fun deploy is going to read the rest of the code in template.yaml here, and we'll go ahead and push my image up to the cloud and set up this trigger for my function. So we can wait a minute for that. And I should point out there's multiple types of triggers. So the type we're using here is an HTTP GET event. That's what will cause my function to run. But I could also cause my function to run I could cause my function to run when a file is uploaded to object storage service. I could call the function compute SDK directly from an ECS virtual machine. I could trigger a function via an event in Cloud Monitor, or even via a notification service notification. So there's lots and lots of different potential function compute triggers out there for you to choose from. While we're waiting for this, actually, I can show you a few of those. So let's do that. So I'll pop over to the help section, go to function compute, and then here in the documentation, we'll have some information about invoking functions. And I think we have a list of triggers in here. Let me look around for that. Let's see, triggers. Hold on just a minute. So Application Center. Oh yes, these are the currently supported programming languages, by the way. We do Node.js, Python, PHP, Java, and C#. But again, you can create a custom runtime. And you do that essentially by creating a custom Docker container. So if you wanted to have your function run a language that's not on here, like Go or C, you could certainly produce a custom runtime that would make that possible. So don't worry if your language isn't supported. You can build your own custom runtime if you need to. In terms of function types, there's, again, a few different ways to invoke them. There are event-based functions and HTTP-based functions. HTTP-based functions are, of course, triggered by HTTP events like get and put or post. Event functions are, of course, triggered by events within Alibaba Cloud. So let me see if we have a list of those in here. I believe we do. I just need to find it. Oops, okay. That's my Docker image getting built. That's why I got that notification. All right. So we do have some examples in here from multiple different programming languages of how you would build an event-triggered function. So there's lots of good stuff here in the documentation for you to reference. I still haven't located the exact spot where the list of function invocation methods is, but I'm looking for that. Here we go, triggers. Okay. So you can see we support the following triggers right now inside of Alibaba Cloud. We have time-based triggers, so you can run your functions like a cron job. We have OSS event triggers, and then there's a whole list of those. So there's multiple events in OSS that can trigger a function. Creating a new object can trigger a function to run. Creating a symlink will trigger a function. Copying an object can trigger a function, and so on. Our MNS notification service can trigger a function. Table store, the CDN, and even log service can all cause a function to run. IoT service and API gateway can trigger a function compute function, as can Cloud Monitor or the message queue for Kafka connector. And then, of course, HTTP triggers are generated by directly making a put, get, or post request to the function compute endpoint. So there's multiple ways to do this. And for each of them, we have examples that you can follow here in the documentation. All right, so it looks like the function built successfully. If I wanted to at this point, I could start or invoke the function locally as a local Docker container. This is a great way to do testing. In my case, I think I should be able to skip this because I've tested the function pretty recently. I'm not expecting anything to go wrong. It's a relatively simple function. So I will just run fun deploy. You can see I did that just now, fun deploy. It's going to use the information I plugged in when I ran fun config. So it's going to deploy in Singapore using my access key ID and access key secret. And actually, before I run this, I really need to make an important change here. I didn't give my user any permissions under my account. So this will fail if I don't give them permissions. So let's give them administrator access and click OK. So now this function compute function has admin privileges, or excuse me, this RAM user has admin privileges under my Alibaba Cloud Compute account. So I should be able to now deploy this correctly. So I'll say yes, go ahead. Okay, it says I did not have authorization. Probably I ran this too fast. Let's try again. Okay, so there we go. Yeah, now it's working, now that I have permissions. And it looks like everything worked. And you can see right here, it warns me that if I try to run this as is, I am not going to be able to see my results directly because the content disposition header will be set to attachment, which means any response from the API is going to be forced to download. So my browser is going to download any response it gets rather than displaying it in the browser, which is what I actually wanted. So I need to go ahead and add a custom URL to this endpoint. So before I do anything else, I'm going to do that. So I have, if I go into the domain console, I already have a couple of spare domains listed here that aren't being used for anything. I think a couple of these, like function time, currently don't have anything associated with them. So if I go over to the DNS console, I can create new records for those. So you can see function time, there's no records right now. We'll add a record in there that points to function compute. So I'll open another tab to the function compute console. I can close this. Let me close that. Okay, there we go. Services and functions. Let's go to Singapore. Okay, there's my meme service and there's my meme function. Great. Everything looks good. Custom domains. We need to create a custom domain. I want to go with functiontime.xyz as my custom domain. And we don't need the CDN, so we'll leave that off. Protocol will just be HTTP. We don't have an SSL certificate, so I can't support HTTPS right now. The path will just be the root. When we make a HTTP GET request to functiontime.xyz at the root, so without anything appended to the path, we'll call this function. And you'll see that I can configure additional routing rules. So I could have /foo go to one function and /bar go to another function. I don't need that though, because this is such a simple deployment. Okay, so there we go. We'll bind our function to this /path, and I can set an alias here, so I can actually do versioning as well with my routing config. So in the future, if I want to upgrade my function, change my function, but gracefully continue the old, gracefully allow the old API to continue running, I can use version aliasing and tagging to enable that. I don't need that again because this is just a demo. So we'll make any call to this URL, functiontime.xyz, trigger our function. So I'll just click OK. Okay, it says the domain name hasn't been resolved to your endpoint. Okay, that's fine. I'll just take this public domain name here, the endpoint, and I'll add it to function compute XYZ's DNS record. So I'll click add record. It's going to be a CNAME record. It's going to point here. Whoops, I accidentally closed that, sorry. Okay, whoops, that should be empty. That should be the value. We want a CNAME record, and this time to live is fine. So we'll have the entire root of functiontime.xyz point to this, which is my function compute endpoint for Singapore. You can see that it's my user ID dot AP Southeast 1 dot function compute.aliencs. So that's just my custom endpoint in Singapore. And I'll click config. Now we're good. Now I should be able to bind that custom domain. Okay, custom domain is bound. So it looks like it's working now. No complaints this time from the system. Everything's resolving the way it should be. Now we can go ahead and test out our function. And there's actually a couple of ways we can do that. We could try running our function using the debugger that's built into the console here, or we could try running it directly from that custom endpoint I set up, which is internet accessible. I think I'm going to do that because, hey, it's already set up, so I don't need to try triggering it from here. I can trigger it directly over the internet. So I have set up some tools to help me do that here in utilities. I have this genurl.py tool set up, and then I have this image fetcher, which is basically just a test implementation of the URL captioning code that I wrote before I wrote my function. So that code was just to help me figure out how to caption the images. So if you look at that, it's basically a non-function compute version of my meme maker that I wrote when I was testing. So going back there, genurl, if we take a look at that code, what genurl does is it generates the function compute call that we want to make. It generates the correct URL string that we need to pass to our browser to make the HTTP GET request that will caption a meme for us. So actually, let's go ahead and run that once and see what happens. So Python genurl. I need to know my function compute URL. Okay, so if I go back to Google Chrome, services and functions, I believe I need to find the endpoint. Here it is. That's the original endpoint for my, or excuse me, that's the trigger for my function compute meme. I think that's right. Okay, plug that in. Image URL, so I need to go to Google Images and find something appropriate. So, grumpy cat. Okay, that looks fine. Let's see, what format is this in? So let's take a look. Okay, so this is, I just want the image URL. So let's open this in a new window by itself. Right click. Ooh, that is a big grumpy cat. Hold on. Right click. Copy image address. Okay, that's just a JPEG. Statically hosted at wired.com. That should be fine. We'll plug that in as the image URL. Custom domain for our function compute function was function_time.xyz. So we'll plug that in as the custom domain. Top text. I need something appropriately grumpy. Let me think about this. I loved cloud computing until I saw my bill. All right, so there we go. So this call here should generate an image that matches that caption and that grumpy cat. So let's see if it works. Let's try it out. So I passed this in. It said, no route found for this path. Oh, I see. Okay, so when I set up my trigger, I said that the path would be function_time.xyz and then just the route. So it wouldn't include this part. So that's my mistake. So let's run the gen URL code one more time. It does remember the previous settings. So I'll just plug this back in without that path on the end. And I'll leave everything else the way it is. It will generate a new URL for me, and then I can copy paste that right into the browser. So let's see what that does. So it looks like something's happening, and boom. So my function fetched the image, captioned it, and then exported it and sent it back out as the HTTP response. So I loved cloud computing until I saw my bill. So it's working. So my meme generator is working. And just to confirm that, it's real and live, we should switch up the image in the caption so that you know that it's for real. So Success Kid. Let's go for Success Kid. There he is. All right, so okay. Okay. Copy image address. Let's make sure. Nope, that's the Google temporary address. That's not the one we want. Open a new tab. This is actually looks like it's a news story. Okay. Copy image address. There it is. Copy image address. Okay. Great. Go back to my gen URL code, which is going to help us make the correct URL call here. Function compute URL is the same. Image URL has changed. Let's see if this works. This might be a little bit long. Function custom domain name is the same. I loved cloud computing. I want to change that. We'll say used function compute saved money. Sweet. And there is our new URL. So let's give that a try to see if it works. So you can actually, if you look closely at this, you can see this is the function_time.xyz custom domain. Then there's a question mark, which marks the start of the URL parameters. The first parameter is the parameterized version of that vox.com image, our JPEG image. And then that's followed by the top text and bottom text parameters, which are also parameterized into the proper URL format with no spaces. So I'll go ahead and paste that in and we'll see if it works. Not sure about that image URL. All right, there we go. Used function compute saved money. So it works. So everything's working the way it's supposed to. That's it. Thank you for joining me for this demo. All right, so I hope you enjoyed the demo. So now let's take a look at serverless Kubernetes. So we'll shift away from function compute and take a look at another way to build serverless applications, which is our serverless Kubernetes service. So again, if you look at the architecture diagram for Alibaba Cloud, at the base layer, we have our infrastructure. That's our public and private cloud networking infrastructure, our data centers where we have our computing network and storage resources deployed. So things like object storage service, cloud disk, ECS, VPC network groups, load balancers, etc. And then, of course, on top of that, you need tools to help you actually run and orchestrate your application. And there are two primary ways to run an application. One is to run it on ECS. This is our virtual machine service. One is to run it on ECI. This is our our Docker container service. If you're using one of our managed Kubernetes clusters where the worker nodes are actually virtual machines that you control, then you'll be using our ECS service underneath. If you're using serverless Kubernetes, where there's no master or worker nodes for you to manage, then you'll be running your serverless Kubernetes deployment on top of ECI and directly using ECI to launch Docker containers on demand. And then, of course, if you look at the far right-hand side of the slide, you'll see container registry. If you're using Kubernetes or ECI, you'll need a place to store container images that you're going to launch your containers from. The best place to do that is the Alibaba Cloud Container Registry, or as we like to call it, ACR. And then, of course, on top of that, you can deploy whatever open source tools you want. Spring Cloud, Dubbo, Istio, Jenkins, GitLab, .NET tools, Java, enterprise applications, whatever. You can run all that on top of Kubernetes easily. In fact, a lot of open source tools are already available as Helm charts, which you can use to directly roll out onto a Kubernetes cluster without even having to do any manual configuration work. So let's break down the different types of Kubernetes clusters that are available. So there's basically three types. There's dedicated, managed, and serverless. If you are running a dedicated cluster on Alibaba Cloud, what this means is the master node and the worker nodes in that Kubernetes cluster are all under your control, and they're all running on accessible ECS virtual machines under your account. You control those VMs, you can log into them over SSH, you can make whatever changes you want to both the master and the workers. But we help you deploy the Kubernetes stack. In a managed cluster, the worker nodes fully belong to you. They are ECS virtual machines under your account. You can log into them and do whatever, but the master is managed for you by Alibaba Cloud. So in a managed cluster, some of the management burden for upgrades and patching for the master node is taken off your shoulders. We take care of that for you, but you still own all the workers. And of course, regardless of whether you're using dedicated or managed, you end up paying 24/7 for those VMs while they're running. With serverless, it's a different story. So with serverless Kubernetes, we launch Docker containers on demand on top of Elastic Container Instance, or ECI, which means that if you define and run a pod or a deployment on your cluster, at the point that you define that pod or deployment, we will go out to the ECI service and deploy X number of containers, however many it takes to fulfill your request. If you cancel that pod or deployment, we'll shut down those containers. So you pay only for the actual pod capacity in CPU cores and memory that you've allocated. So there's no servers for you to manage, no ECS instances. It's all happening on demand based on the pod or deployment configuration that you sent to the Kubernetes service. And there's no master node for you to manage. You can still use kubectl, the Kubernetes command line, with serverless Kubernetes on Alibaba, but the kubectl commands go to a Kubernetes master endpoint that we manage, and they cause pods to get launched on ECI. So this is the cheapest option, and it's also the lowest overhead. There's nothing for you to manage. All of it is taken care of for you by Alibaba Cloud. You just call the kubectl command and send your deployment.yaml and your services.yaml files over to us, and then we take care of the setup on the back end for you. And that's all based on ECI. So Elastic Container Instance is basically a way that this is the method we at Alibaba Cloud use to manage the running of Docker containers. Under the hood, it's the same hardware we use to run our ECS virtual machine service, but there's a very lightweight hypervisor on top of that machine, and there's just a single Ali Cloud Linux VM running. There's a series of micro VMs running, one for each Alibaba Cloud customer, very lightweight, and within that we're running the Docker container engine. So we're able to use ECI to effectively share the cost of the underlying physical hardware by launching multiple customers' containers together in this lightweight environment that actually runs very similarly to the ECS service. And this way we don't have to charge you for the whole virtual machine, we just charge you for your running containers. It's a way to subdivide our hardware into even smaller chunks so that we can charge you less money. If you go fully serverless with ASK, with Alibaba Serverless Kubernetes, essentially the way this works is we set up a virtual node for you, a virtual worker node that is actually represented by the ECI service. And when you launch a new pod, it gets deployed onto this virtual node, sent over to ECI, and then ECI runs however many however many Docker containers are needed. And you can go hybrid. So you can see on the left side of the slide here, I can have a traditional dedicated or managed cluster that also has a virtual node attached. So if I run out of capacity on my standard worker nodes on the Alibaba Cloud ECS service, then I can still scale out to ECI using this virtual node. This way I can use a dedicated or managed Kubernetes cluster to deal with stable, steady workloads, and then use the virtual node to scale out when I have an increase in demand. That can be a good way to achieve cost savings. So hybrid serverless is a popular model with a lot of our customers. They will buy a long-term lease for ECS, which gets them a big discount up front. They'll then run their Kubernetes workers directly on ECS, but they'll attach this virtual node that we have in our Kubernetes service to their cluster. And when they run out of capacity on their ECS workers, they'll push jobs onto ECI, which is pay-as-you-go. Obviously, pay-as-you-go pricing is typically more expensive than long-term subscription. But this is a great way to get the best of both worlds. For your average workload, you run that on long-term subscription ECS, which is the cheapest possible option. And then for sudden bursty workloads, you scale out to ECI. This is a good way to get a nice mix of the serverless Kubernetes service plus dedicated and managed Kubernetes. And this lets you control costs by mixing a subscription with pay-as-you-go, as you can see in this slide here. This lets you meet demand in a slightly more flexible way. So how does this all work under the hood? It's a little bit complicated if you're new to Kubernetes, but essentially, regardless of what type of cluster you're using, there will be a Kubernetes master node somewhere that runs the Kubernetes API server and the etcd daemon. Etcd basically serves as the file system for the Kubernetes master node. It's where all the cluster configuration information is stored. When you talk to the Kubernetes API server, you do that by sending it these YAML files that it will then check against the status of the cluster. So I can send a stateful set or a deployment YAML file from my machine to the Kubernetes API server. It will interact with the cluster to see what the difference is between the current state of my cluster and the YAML file I submitted, and then it will bring the cluster into agreement with the configuration I just submitted to the master. Of course, if you're using the virtual node, the Kubernetes API server actually interacts with the ECI service on the back end through that virtual worker node. So from the Kubernetes API server's perspective, there's just a big Kubernetes worker node sitting there waiting for requests that has as much hardware as you want, but behind the scenes, what's actually going on is the virtual node is sending requests out to ECI to launch your pods. And of course, you can report pod status from ECI back to the master using our built-in monitoring tools. We have a version of Prometheus that we implement that can talk to the pods running on ECI, as well as other services like Cloud Monitor. So a great use case for serverless Kubernetes would be something like building a CI/CD pipeline. So continuous integration and continuous deployment is characterized by periods of inactivity, followed by periods of intense activity when a new update is deployed. So as soon as someone submits code, then you'll need to run your GitLab runner or your Jenkins job, do your integration tests, build your code, maybe run some Terraform scripts, deploy everything, and all of that is going to require resources to run. But when you're not submitting new code, this entire pipeline is sitting quietly not doing anything. So a CI/CD pipeline is a great use case for a serverless Kubernetes cluster because you won't pay any money for this cluster when it's not doing anything. You can shut down all your pods when nothing is running and then fire them up when new code is submitted. I think that's enough to give you the gist of serverless Kubernetes. I think you get a pretty good idea of what it is. It is just a regular Kubernetes cluster, just like any other cluster, except that behind the scenes, we are using Elastic Container Instance to launch Docker containers, to launch your pods on demand, rather than running them rather than having ECS instances running 24/7 to act as Kubernetes workers. So we've adjusted the architecture so that you pay less. Container registry, let's now take a look at that. So container registry is a tool for building and storing Docker container images. So it's a cloud-native tool. It runs fully within Alibaba Cloud, and it integrates with our other cloud services. It has built-in security tools. It lets you define your own user-defined domains and network ACL rules. It lets you implement server-side encryption for your images. It lets you sign them with a KMS encryption key, and it can even do security scanning. It's also great for large-scale distribution. So if you have a Kubernetes cluster that's thousands or tens of thousands of nodes in size, and you need to push out a new Docker image, obviously that can create a pretty severe network bottleneck when all those worker nodes try to fetch the new image. We have a peer-to-peer distribution tool that actually solves that problem, which is how we do our internal deployments. So when we deploy something for 11, we can roll out a new container image that's a few hundred megabytes in size to 10 or 20,000 nodes at once in just a few seconds. And then image replication, especially if you're using the enterprise edition of Container Registry, image replication is a cool feature that will allow you to automatically push a new container image out across multiple regions. So you can push one from Hangzhou to Singapore to Japan all in one step, built into the service. So this would be a full container registry pipeline based on the enterprise edition. I could push a new image up to the repository from my local machine. ACR, so Alibaba Container Registry, will then scan that image for vulnerabilities, make sure it's clean, sign it with an encryption key from KMS, validate it, and then push it out to Alibaba Cloud's Kubernetes service. If a user tries to deploy an image that hasn't been signed with the KMS key, then the Kubernetes service will reject it. So this allows you to ensure that all of your images have to go through Alibaba Cloud Container Registry. No one can push a rogue Docker image out to your cluster. Global image distribution. This is that feature I was just talking about that lets you push a container image from one region to another. If you've worked in China before, you'll realize how valuable a feature this is. If you want to push or pull container images across the Chinese border, it is super slow and a little bit glitchy. So it's best actually if you can have some automated service like this that can go cross-border for you automatically. This is a key feature of Alibaba Cloud's enterprise edition of our container registry. I can build an image in Singapore or Hong Kong, push it to Hangzhou. I can take an image I built in Hangzhou, push it across our private network infrastructure into Hong Kong, Singapore, and London really, really quickly. So especially if you have Kubernetes clusters running in multiple different regions, this cross-region push is a really cool feature. And regardless of whether you're using the Enterprise Edition or not, if you are building applications for the Chinese market, you can actually run the build outside of mainland China. So if I'm in Container Registry and I push a new Docker file to GitHub, and Container Registry sees that new Docker file, when it pulls that Docker file and does the build, it can actually make sure that the build happens in a region outside mainland China. That way I can communicate with Docker Hub faster, so that accelerates my builds. And then it will push the new completed image back into Hangzhou or Shanghai or whatever my original region was. Large-scale distribution, again, we use a peer-to-peer image distribution tool, which can improve new image pushes out to your Kubernetes workers by about fourfold. So it can speed that up about fourfold. So if I push a new Docker image to ACR, I can push that out to a Kubernetes cluster, even one with thousands of nodes, in just a few seconds. Full cloud native support. Our container registry service works great with open source tools like GitLab and Jenkins and Kubernetes. It will work with all those things. So I can easily combine my existing open source tool sets with container registry. I can use it just like I would use Docker Hub. So let's have a demo of that. Let me show you how that works hands-on. All right, so welcome back. So let's have one more quick demo here. So what I'm going to do is show you how you can use Alibaba Cloud Container Registry and also Alibaba Cloud Serverless Container Service for Kubernetes. So to get started, I'm going to create a GitHub repository. We're going to save some code into that repository, specifically a Docker file. When we update that code, that will cause Alibaba Cloud Container Registry to basically automatically build a container image for us, and then we'll be able to run that on our serverless Kubernetes cluster. So we need to do a couple of things. The first thing we need to do is go over to GitHub and create a new repository. So we'll do that right now. So I'm here in my Your Repositories list. If I click on New, I can create a new one. We'll create a new one called ACR Test, and it can be public or private. Let's make it private. My first test of Alibaba Cloud Container Registry. And we'll add a README, I guess, and then we'll create. And that should get things set up for me. Actually, I created a test earlier that I need to delete from my desktop first, so let's get rid of the old one. Yes. Oops. Should have done rm-rf. There we go. Deleted the old one. Let's go ahead and download this new one. So I'll clone that, git clone, ACR test. That should clone into my repo. I can go to ACR test. I can see the README. I should be able to edit the README a little bit. Let's actually do that. Let's add some content to the README. Here we will test pushing Docker file updates to ACR via webhook. Okay, I've updated the README. If I run git status, I can see it changed. I can add it to the list of changes to be committed. My first commit. I can then, oops. Yeah, looks good. Git push. It's complaining a little bit about my username. I should probably edit that to make it look nicer, but we'll leave it the way it is for now. Okay, great. Git status. I'm now up to date with the master copy of my repo here on GitHub, and I can see the extra line is showing up in my repo here, so it looks like everything's working fine. We can push updates to the repo just fine. Now what I need to do is configure container registry. So I'll go over to the container registry console. I just go to products and services, search for container registry, and then it shows up here in the search results, and I can go right to the CR console. We can use any region we want, inside or outside China. I think because I'm in China, I'm going to go ahead and use Hangzhou. So let's use Hangzhou. And obviously I haven't bought the Enterprise Edition since I'm just doing a test. So instead we'll use the Personal Edition. There are no code sources, namespaces, or repositories set up yet, so we need to take care of that. The first thing we need to do is bind to GitHub. So there's a handy button here that says bind account. I'll click on that. It will ask me to go to the source code repository to bind the account. Great. I click on the link, takes me over there, click authorize, takes me back to Container Service Console. Not sure if that actually did anything, so let's refresh and see. Okay, it looks like that might not have worked, so let's try it again. You've successfully bound GitHub. All right. I clicked OK. Everything's confirmed. Good. And it says bound. Okay, so it just takes a minute to show up. Great. So I can close those extra tabs now. And next I need to set up a namespace. A namespace is like a high-level structure where you can host multiple repositories. And each repository can, of course, have multiple Docker container images in it. So you might have one namespace per team in your company, one namespace per department in your company, one namespace per application, totally up to you. I'll just create one called JDP namespace. That should be fine. And then I'll click confirm. I will leave it set to private, and then I'll go to repo and I'll create a repository within that namespace called, we'll call it Nginx Web App. So you can name the repo based on what it's for or what team it belongs to. Again, that's up to you. I'm going to name my repos based on what application they hold. So in this case, Nginx Web App, I'll make it private. And I'll say an Nginx-based web application front end. Front end. There we go. Need to spell that right. Okay, next, I will link to my GitHub account. the repository ACR test, and I will build images automatically whenever code changes. And you'll notice I also have options here to build with servers outside mainland China, or to build without caching if I want. Building with servers outside mainland China is actually a good idea for many images because it will accelerate the build if you're relying on a base image that's on Docker Hub. So actually, let's use that. We'll build with servers outside mainland China, and then I'll click Create Repo, and that will create our repository for us. Now we've got our brand new repository. If I click on that, it will show me how I can use the Docker command line tool to log into that repository so I can manually push and pull images. That's one way to make use of the repo. The other way is to have builds that occur automatically when I change source code that's stored in another service like GitHub. That's the method we're going to be using to trigger our builds. So the way things are set up now, I have one build rule already that will look in my ACR test repo on GitHub for a Docker file at the root of the repository, and it will look for a GitHub tag that's release -v and then a version number. So that's what it's going to be looking for. So let's go ahead and set things up. I'm going to create a new Docker file from Nginx latest, and we'll just put one line in there to test right now. Just one line. And if I wanted, at this point, I could do Docker build on that Docker file directly. And that would build it here locally on my local machine, which will let me test it if I want. So I can now see I have just built this image. I've got a couple other images sitting around from function compute testing that I did earlier. The one I just built, I believe, is... Actually, I don't see it in my list, sorry. Docker images. There we go. Okay, so it looks like it's this one that's got no ID. So actually, I should have given that a name. So let's give it a name. So we'll say Docker build tag my web app or my Nginx app. That way the image will have a tag and we'll be able to see it more easily. Let's rerun that. My Nginx app, there it is. All right, so I can actually see that image now. It was a little bit hard to tell which one it was before it had a tag. So it's a good idea to give your images a human readable name. I could then try to run that, my Nginx app, and then I'd have to give my container a name. And then I would need to say what port I want to bind to. Oops, sorry, I think name only has one hyphen. I would need to say what port I want to bind to on the host so I can actually access Nginx from my local machine. That should run things for me. Whoop, excuse me, I did not run the run command correctly. My bad. So we need to rewrite that command. My bad. All right, so Docker run Docker images again. Docker run my Nginx app. I think I can put the name part afterwards. Let's do that. Nginx container port 8080. Let's see if that works. Oh, nope, it doesn't like that. All right, Docker run name Nginx container 8080. And then my Nginx app. Oh, I'm sorry. I'm going to have to check the command syntax. I'm not sure what I'm doing wrong here. I must have done something that it doesn't like, but I haven't figured out what yet. So let's take a look at the run commands. All right, so Docker run image, and then options should go first. All right, so that seems correct to me. You know what? Maybe I won't give it a name. We'll just do that. 8080. Nope, still doesn't like it. All right, my bad. Let's fix that now. Maybe that has to go in front with the options rather than the arguments to the container. All right, there we go. Now it's happy. My bad. So yeah, with Docker flags, you have to be a little bit careful about what order they go in, but it looks like things should be fixed now. And because of the way I ran the run command, it's going to sit here in the terminal, so I'll be able to see any output from Docker here. You can also run containers in the background. I chose to run it like this so that I can Control-C to kill it when I'm done. So if I run docker ps, I can now see this container running. It doesn't have a name, it just has this ID number, and it's been running for 27 seconds, and it's bound to port 80. So now I can go to localhost 80, and I should see my welcome to Nginx page. So it did work. All right. So now I've confirmed that the container does what it's supposed to do, which is run Nginx. And now that I'm happy with it, I can go ahead and actually commit this to Git. And hopefully that will trigger a build in my Docker container registry here up on Alibaba Cloud. So if I run git status, I can see this Docker file needs to be added. Git add Docker file. Okay, it's been added. Git commits. We'll run a commit. New Docker file. All right. Oops, my bad. That last quote mark, I had my Chinese keyboard turned on. There we go, that's fixed. Okay, so we need to tag this. So I need to do git tag release vo, and then the hash for our commit. If I run git show again, we can see this has now been tagged release vo. And I need to push those tags up to the repo so that they exist on the remote side as well. By default, GitHub doesn't, or excuse me, the git command doesn't push new tags up to the repo. That's a separate step, so I have to run git push -- tags to get that uploaded, and then I just run regular old git push to push my code. And once that's done, my Docker file should show up here. So if I refresh, I can see that I now have a Docker file showing up here. And I have one tag that I just pushed, which is release vo, and that tag points to this commit here with the new Docker file. So if I go back to container registry, we should see a build executing. So let's see if that's happening. Sure enough, down here in the build log, I can see that the build status is building. And if I check out the log, it will show me what's going on with that. It looks like the build has actually already completed. So if I refresh, I should see that this build is complete. Sure enough, it shows up as successful. That means that the container image now exists in the container registry repo that we just built. So our Nginx web app image was automatically built inside the container registry service based on that change we made to GitHub. So I pushed my new Docker file to GitHub. I tagged it with release -v and then a number, just like the tag here says to do. When that happened, the container registry service went back to the repo, looked in the root folder here, ACR test, saw the Docker file was located there, and then automatically built an image from it. So now that I've done that, I can deploy new Docker containers onto Alibaba Cloud's Elastic Container Instance Service or onto Kubernetes directly. So let me show you how this works with Kubernetes. So I need to go over to container service for Kubernetes. You know what, let's just search for Kubernetes. There we go. And that will take me over to the Kubernetes service. Okay, no clusters, let's make one. So create a cluster. Region, we will put it in Hangzhou because that is where our image is. I'll call it K8s cluster serverless. We will use serverless Kubernetes. Oops, K8s cluster serverless. Region Hangzhou. Oh, can't use that name. Oh, you can only use hyphens. Okay, we'll use hyphens. I need to choose a Kubernetes version. I'll go with 1.18. I can choose to launch this in an existing Alibaba Cloud VPC group, or I can create a new one for the cluster. I'll create a new one. We'll use Hangzhou Zone K. I think that's the newest zone. I will attach a NAT gateway. This will actually allow my containers to reach the internet. This can be a good idea if containers need to communicate with external services to fetch updates or to communicate with public cloud APIs on other clouds or other services. So I'm going to add a NAT gateway so my containers can reach the internet. I need to decide on a private network address range for my VPC network group. I'll leave the default. I'll make the API server accessible from the internet. This is a good idea if I'm going to need to run kubectl commands against my cluster. We'll just use the default load balancer to do that. If I want, I can turn on Core DNS or Alibaba Cloud's private zone so that I can publish private DNS records in my VPC. This is very helpful if I'm building a microservices type application where each component needs to have some public name that maps onto an ever-changing IP address. My application is a super simple monolithic single container application, so I don't need this. But if you were building something more complicated, you'd probably want private zone or Core DNS turned on. I can include an ingress controller if I want, which will allow me to route different HTTP requests around to different services within the cluster. This can be really, really helpful if you're building a web application that actually hosts multiple services. So maybe you've got like /frontend pointing to your front end and /API pointing to your back end or something like that. Then it's a good idea to have an ingress. I can skip that. I can turn on advanced monitoring if I want. That will let me collect additional metrics about my serverless cluster's health. I'll leave that off. I will turn on log service. That will allow me to see logs about my cluster. That's super important. I recommend you stick with the default and turn that on. If I want to use the Kubernetes serverless framework, I can enable Knative right here. And then, of course, I have to set a time zone for my cluster, and I can turn on deletion protection as well if I want, which will prevent me from accidentally deleting this cluster. That's especially important if this is a production cluster. Mine isn't, so I'm not going to check that box. I'll just agree to the terms of service, and then we'll click on Create. And what that will do in the background is actually run a resource orchestration service script. So we have a service called ROS, which is a lot like AWS CloudFormation. We'll use that to set up the whole stack that's going to make this work. So this will set up our VPC group and our NAT gateway and our networking rules, et cetera, et cetera. So we're ready to go. Right here, the cluster is telling me what I'm going to be charged for, just so that I know what the costs will be. So it looks like I'm going to have to pay the regular pay-as-you-go rate for log service and NAT gateway, but everything else I'm setting up should be free for now. And then I'll click OK, and that will start the cluster creation process. This can be a little bit slow. It can take 3 to 5 minutes to set up the cluster. So we'll give that some time to complete, and then we'll come back when it's done. All right, so after waiting about 3 or 4 minutes, my cluster is now up and running. I can see that here under cluster status. If I click on the cluster name, that will take me to the cluster dashboard, and I'll be able to see some additional metrics that tell me about the health of my cluster. Right now I have 0 stateful sets, 0 pods, 0 deployments. So there's nothing running on the cluster, which is great because that means I don't need to pay for anything. Well, that's not quite true. I have a log service logging project set up, and I also have a NAT gateway. So obviously I'm paying for those, but I'm not paying for any running pods right now because I have 0. So what I want to do right now is actually deploy my Nginx container. So to do that, I'm going to create a deployment. I could also just directly create a pod, but it's a much more common practice on Kubernetes to directly create a deployment, which will run multiple replicas of your pod simultaneously. And I can create from an image or create from YAML. Let's go for create from image. So I'll call it Nginx server. We'll make 2 replicas of it. We'll set up a deployment to run this. I won't give it any labels. I'll just click next. The image name, I can click on select image because I'm using my private repo. So you can see here in container registry, I already have this JDP namespace Nginx web app. So I can pull this right from the Alibaba image repository that I set up. So I'll do that. Click OK. Image version, there is no version actually. So I guess 0 is the version. We'll go with that. Image pull policy, I will go for if not present, so I'll pull the image if I don't already have a copy. I will allow this to have 2 CPU cores and 4 gigabytes of RAM. I won't pass any starting parameters. I don't need to do anything to initialize the container. Nothing special is required. And I want this container to listen for requests on port 80, TCP. Liveness and readiness probes, these are a Kubernetes feature that allows me to have the container perform certain checks or wait a certain amount of time before it starts receiving requests. My container is really simple, so I really don't need to do that. Lifecycle parameter configuration. Again, my container is very simple and stateless, so it doesn't need to do anything special before it shuts down. It doesn't have any pre-start or pre-stop workloads, and it doesn't need to bind to any volume. So I should be able to leave all of that blank. I do want to create a service that points to the container though. So I'll call that Nginx server service. It will be accessible from the internet. That way I'll be able to reach my containers. It will listen on port 80 and it will forward requests on external port 80 to the container also on port 80. So that looks okay. I can choose a different type of SLB if I need a bigger one, but the slb.s1.small should be fine. Click create. I don't need to set up any kind of HPA. This allows me to horizontally scale a collection of pods to meet demand. For the demo, I don't need that. It's probably a good idea to turn that on for a normal production web service, but I'll leave it off. And then I'll click create. So that should create my deployment and my service. So let's see how that's going. So you can see that I have 2 pods starting up. That's how many I said I wanted. They are probably waiting for that image to get pulled down from the container repository first. Let's look into deployments, services, excuse me. So under services, I have the default Kubernetes service and I have my Nginx server service, which is going to be listening on this public IP on port 80. So it looks like that's pretty much ready to go. The setup looks fine for that. It's got 2 pods that it's connected to. Let's go back and look at the status of our deployment. Those pods are both running. So if I go down to my service, plug that into my web browser, I get welcome to Nginx. And the really cool thing is that Kubernetes is actually taking care of load balancing and everything between those 2 containers for me. So if I delete one, let me do that now, this URL should continue to work. So yeah, I'm still able to reach out to the one running container. And what's better, the Kubernetes cluster will detect that my deployment only has 1 pod running, and it will create a new pod to get us back up to the requested number of pods. So once that first pod has terminated, you can see the service is already starting up a new pod to take its place. So if I go back to my deployment list here, I have 2 of 2 pods running again. So even though I deleted one, the cluster detected that my deployment requires 2 pods, but only 1 was running, and it rectifies this problem by starting up a new pod for me. So that's a cool feature of Kubernetes. It will always compare the state of the cluster to my deployment and service YAML files and make changes that are necessary to bring the cluster back in sync with what I asked for. So if I'm not running enough pods, new pods get created automatically. Load balancing is also handled automatically by the cluster, so you'll notice that my welcome to Nginx page kept working even when I deleted one of the 2 pods. So everything's working and my serverless cluster is now running a service on this public IP address and port 80 that maps onto these 2 pods. And these 2 pods, you can't see it from here, I don't think, but these are running on ECI. They're running on Alibaba Cloud's Elastic Container Instance. So all of this is happening for me automatically in the background. I can even scale up if I want. If I wanted, I could go up to 4 running containers. If I click OK, that will immediately start up 2 new pods, and then I'll have a total of 4 running. So you can see now we have 2 of 4 pods live. If I wait a little bit, that should eventually become 4 of 4 once those pods are successfully placed into a running state. Let's see how we're doing. So 3 are running now, 1 is pending. Okay, all 4 are running. So if I go back to the deployment, sure enough, 4 of 4 pods are running. From the user's perspective, I don't really notice any change. Things keep working the way they were. And that's it. That's how you create a container image using Alibaba Cloud's container registry, and then create a deployment on a serverless Kubernetes cluster using container registry. So pretty cool stuff, right? I can go straight from code in GitHub to an automatic image build in the container registry service, and then over the Alibaba Cloud private network, I can pull that image down onto a Kubernetes cluster, create a deployment, create a service mapping to that deployment, and then push that out to the public internet. It's that easy. And that's it. Thank you for joining me for the demo. All right, and that's it. That's all for today. I want to thank you very much for joining me. And of course, if you have any questions, don't hesitate to reach out to the Alibaba Cloud team. We're always here. Thank you, and see you next time.
Are you looking to establish a global online presence but worried about the painfully long turnaround time of app development? Meet Nancy, who feels the same. Nancy is the digital head of an e-commerce company that is gearing up for a global online shopping festival. She wants to build a customized shopping app for mobile devices with multilingual and multi-currency support. Typically, an app like this takes months to develop, test, and launch. However, Nancy only has a week to roll out the app and decides to adopt the DevOps methodology to complete the project. Nancy realizes that this is easier said than done because to transition from a traditional development method to DevOps, her organization would face multiple challenges, such as difficulty adopting a DevOps culture. Traditional departmental silos must be replaced with cooperative and cross-functional teams to build an overall DevOps culture. Absence of an implementation plan. Nancy's organization lacks a DevOps implementation plan with well-defined milestones, deliverables, and project owners. Lack of necessary skills. Nancy's team is not accustomed to the new skills that DevOps requires. Her team needs to learn new tools to ensure continuous integration, infrastructure automation, containerization, and orchestration. Infrastructure incompatibility with DevOps. The organization must ensure that its existing infrastructure is compatible with DevOps technologies to deliver an enhanced user experience. Nancy is in an urgent need for a professional DevOps solution provider. Alibaba Cloud is the perfect choice for Nancy because it offers end-to-end DevOps solutions by combining the flexibility of DevOps with the power of the cloud. What's more, Alibaba Cloud experts provide professional guidance for organizations to successfully adopt DevOps. With its DevOps solution, organizations can enjoy detailed DevOps implementation plans. Alibaba Cloud experts provide DevOps implementation recommendations, which include well-defined milestones, deliverables, and project owners. Use of automation tools. Alibaba Cloud experts help organizations use proper automation tools to deliver results at a faster rate. Elimination of downtime and security vulnerabilities. The efficient monitoring and automated testing tools of DevOps eliminates downtime and security vulnerabilities. Breaking the rigid network infrastructure. Using DevOps in a centralized programmable network, organizations can automatically address changing requirements and reduce the CapEx and OpEx by enabling algorithm control of the network. With Alibaba Cloud's experienced professionals and DevOps support, Nancy's organization was able to achieve 2 times faster software delivery speed, 72% better software performance prediction and delivery, 64% improved software quality with fewer defects, 2 times better cost control for services and tools used, 65% improved customer experience than the baseline of traditional software development and delivery models. Nancy's global shopping app was a huge success, thanks to the power of DevOps. You too can make the most out of DevOps and the cloud. Talk to our experts today.
We're speeding into the fast lane with Globe's 5G technology. It's fast, it's fun, it's wonderful. It's Kim Son-ho approved. With Globe 5G technology, the possibilities are endless. It's about time we inspire the youth to create something meaningful, spark reinventions, and improve the framework of the future. That's what the 5G Hackathon is about. Students, professionals, and startups are welcome to join the event by registering using this link. Once accepted, you may enjoy access to the Globe 5G Hackathon HQ, where the enablement workshops will happen. That's 2 weeks worth of fun workshops and mentorship by industry experts from our tech partners. All these to get you to the top. That doesn't end there. Apply what you've learned from the workshops and pitch your idea on how you can use 5G to improve the way we live. The panel will pick the top 30 semi-finalists to join the pitch competition and enjoy exclusive workshops and consultations with mentors. But if you're truly, madly, deeply at the top of your game, you can be chosen as part of the top 10 finalists who will proceed to the Hackathon Finals. 3 of the best pitches will be hailed as winners. What's in it for you? Well, over 500,000 pesos worth of prizes will be given away, plus a chance to be part of the Venture Builders program of 917's Venture Velocity and work directly with Globe 5G Acceleration Lab. This is powered by Globe and Animal Labs by DLSU. Thanks to 5G, we're about to achieve great heights. Click the link and show us what you've got. Get ready to reinvent your power to create change. Register now.
Do you want to make a difference and reinvent your world? 네, 안녕하세요. 여러분, 김선호입니다. 샌드박스 같은 곳에서 경쟁하는 기분을 느껴보고 싶으신가요? 그렇다면 글로브 5G 해카톤에서 진행하는 워크숍과 멘토십을 통해 5G 활용 방법을 만들어보고 여러분의 친구, 동료들과 팀을 만들어서 디지털 시대 속 필리핀의 새롭고 흥미로운 가능성을 열어보세요. Follow your dream. Register now.
Why don't you watch me do my thing? Reinvent the world, yeah. Just to be more, just to be better, just to evolve, just to evolve, just to be more, just to be better, just to evolve, just to evolve. Every time the world spins round, reinvent 360. Thinking you gon' mess up your thing, yeah. Show the whole world, reinvent. Nobody should know something. It's strong, ain't a good time. 1, 2, 3, ready to try. Why don't you watch me do my thing?
Take it to the next level with Globe's fiber, LTE advanced, and 5G mobile connection. Now you have the power to reinvent your world. Globe.
The new mind-blowing Surfer 99?
9 gig? All sites?
For all devices?
Shareable with up to 4 people?
Like my fam? Anywhere they are?
The new mind-blowing Surfer All 99.
Dear Mother, Light of the Home.
Dad?
Hey, baby!
Greetings, Professor Rodolfo.
May I be absolved from
Math Club tomorrow.
May Globe Virtual Hangouts kasi.
Go and hang out from wherever you are. Just open the Globe One app, choose an event, and click join.
Watch concerts online!
Woo! Dance together!
We can do quiz nights.
Yo, let's go! If you allow me,
I promise
To make it up to you.
And repay your kindness tenfold. Truly, your favorite child.
I love you, Dad.
please, babe.
Thank you, sir.
Enjoy your fave events with Globe Prepaid Virtual Hangouts. All together now.
Get it? Yeah. 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 Get it?